two will take place today and two tomorrow. So we start today with our keynote by Etien, and then we will take a short break. How the breaks will work will be explained by Anna in a little bit. Afterwards, we'll have a session about introducing the hackathon. And then yet another break. You will notice we have quite some breaks because it can be very tiring in an online setting to be in session after session. Not that it's easier in a physical setting, but it's even harder in a virtual setting. Afterwards, we'll continue today with two paper sessions about legacy and microservices, and then about mining software repositories with a break in between. And then we will close the day, but we will keep our amazing hackathon team online for 25 more minutes in the end, in case you have questions about the hackathon. So you can go on Discord and interact. Of course, this you can do throughout the day, but that specific time slot is dedicated if you want to go and chat about the hackathon. So this is for today, and then tomorrow we will open the day a bit later. So please keep in mind the times are in UTC. If you're here, it means you probably already know it. I tried to point it out in several emails. So tomorrow we will open the day. We will have one paper session about evolution and dependencies, then a small break. Then Tom Menz will give his keynote speech, and then another break, another paper session about the evolution theory and practice. And then we will have one last session about the hackathon results. So here, once you have your results, you will contact the hackathon team, which is Miroslav and Nuria here. And then the organizing team will arrange time slots so that you can present your results for the hackathon. And then we will close the event tomorrow at 3:10 UTC time, which means for European participants in our time zone 5:10. But please use a time converter just to be sure that you're here on time. So as I mentioned, we have two keynote speakers, and I would like to thank them both for accepting our invitation and arranging these wonderful keynote speeches. So thank you, Anne. Thank you, Tom. The first keynote is today, right after the opening, by Anne Etien at the University of Lille. I will not present the keynote speakers now, so this will be done during the keynote speeches. Please attend. It will be very, very interesting keynotes. And then Tom Menz at the University of Mons, who we know and love. So please attend the keynotes. They will be very interesting. Now, Anne, I give the floor to you.
Yes, thanks a lot. We use Zoom for the presentations, and we use the Q&A part. For posing the questions, you'll find text channels for each session where you can drop being presented. Our great student volunteers will collect them and descending in order of popularity and send them to the chair, so the chair can then voice these questions or keynote. If time allows, then we'll also open the floor to there are still things that you'd so to speak, so people that also have some discussion to conduct with the presenter of that paper. Finally, we also have a lobby and coffee tables. So we try to mimic a little bit the behavior of an actual conference, where you might just stumble upon people that have an interesting conversation and you'd like to listen in or pitch in. So that should be very easy to do through the voice channels in Discord. If you have any questions for us, you can always simply tag in the general @organizers and then ask your question, and then someone from the organizing team will try to very timely reply to your question. That's about it on our side. I hope it was clear. If not, we will repeat these things as we go on. The Discord link, if you didn't make it yet in Discord, the Discord link is on the slide here. Please join us. If you can't figure out how to do that, just shoot an email to me or Eleni or some of the student volunteers, or all emails are listed on the SATToSE webpage. So it should be simple to find us somehow and to get into the community. Yeah, that was all on our side for now.
Thank you, Anna. And especially for the coffee breaks, at least my plan is to grab actual coffee and go on Discord and join the break channels to, have some nice chats there as well. So we'll be more than happy to also chat there. Now, of course, I would like to thank all the participants. Although it's a virtual event, we had 40 registered participants, so a big thank you for being here today and tomorrow. Most of our participants are from Europe, so we have 18 participants from the Netherlands, 9 from Belgium, 3 from Spain, 2 we have actually from Germany and Sweden, and then we have 1 participant from Brazil, 1 from the US, and 1 from Canada. So thank you all for participating in this new way of holding SATToSE. We hope and we will did our best to have a wonderful SATToSE given the circumstances. So a big thank you for being here and making this happen. And last but not least, we still need our social presence of SATToSE on social media. So usually we are on Twitter, and please use the hashtag SATToSE20 to either promote your presentations, discuss about things you've heard at SATToSE. So let's keep SATToSE live on Twitter as well. So that was it on my side, and it's time to open SATToSE. I will give the floor back to Anna so that we can start with the keynote.
Thank you very much, Eleni. It's been great working together so far to organize, so I'm very excited to get started. I would like to introduce Etien. I mean, if there's any need to introduce Etien to our community. She was our great program chair last year in Bolzano, and she was very, very kind to accept our invitation to give a keynote today. Soon to be full professor at the University of Lille in September, so we are very honored as well by that. And she, of course, she's been acting in many of the program committees in ICSME and ICSI over the years. So it's absolutely an honor, and we are looking forward to her presentation. I know she has a Who Am I slide, so I don't want to take too much away from her own bullet list there, bullet points, I mean. And I'm really looking forward to hear more about those rotten tests. So the floor is yours, Anne. Please.
Thank you.
Go ahead with your presentation.
Okay.
While we are setting up, don't forget to ask all your questions and discussion points in the Discord text channel labeled Keynote 1.
So normally you should see now my slides. Yes? Okay, great. So yes, I will talk to you today about rotten green test, and it is a work that we did in 2 phases. So during the first one, it was with Julien Delplanque, Stéphane Ducasse, Guillermo Polito, and Andrew Black, and the paper was accepted in ICSI 2019. And the second, and it was in Faro, you will see. And the second phase was we added Vincent Aranega, Matthias Martinez, and Christopher Foreman, and it was in the 3 language, Python, Faro, and Java. So first I will just quickly say who I am. So I am almost professor, full professor at the University of Lille, so it will be starting from September, as Anna said. And I am member of the ERMOD team that is joined with INRIA Lille Europe in France and University of Lille. So some topics that I am working on is architectural modularization, software transformation, database evolution, UI migration, API update, test selection, and so on. But mainly, if you have to only retain one thing, it's maintenance of an evolution of legacy software systems. So now I will tell you a story. So in my team, every last Friday of the month, we are doing a sprint because we are developing FAO, an object-oriented language that is also an environment. And so one day, Andrew Black, an American guy that is also participating to FAO, was saying that there is a bug somewhere in a collection, in the collection API. And so some maintainers say they run the tests were green, and they say, okay, everything is all right. He said that there is a bug, but there is a test covering these parts, so the test is green, so everything is all right. And so the issue was closed. Some years later, he reopened the issue because the issue remained. And 2 years ago, in 1918, he came to visit us in Lille, and during one sprint, he explained to us what happened, and he said, yes, there is a test, but in fact, the assertion is not executed. So there were really a bug, and we will see it after. And because we discovered this problem, we were looking if this occur several times in our system. So we call this kind of test a rotten green test. So what is a rotten green test? So so here on the left you have the FAO test and a version of the test, and on the right you have the Java version of the right. Because it was firstly discovered on FAO, you will see a lot of FAO code, but you will see also Java and Python. So you have a test, you are declaring a variable, you are setting it, you are adding value, and you have an assertion, and so on. So this is a test where you have feature, stimuli, and assertion. A smoke test is a test without assertion, and it is not a rotten green test. What is a rotten green test? A rotten green test is a test that is passing, so it is green. It is a test that contains at least one assertion, but on which one or more assertion is not executed when the test runs. So, what am I talking about? So let's see some examples. So here you have a test, and if you have a condition, so for example, to simplify, if false, then self-assert x, so your assertion will be never executed. And so it is what we call a rotten green test. Because when you execute this test, it will be green. So let's see a real one. So here you have, so it is in FAO, you have a test, you have some variable, a stream result, all elements are streams that are variable, you have a result that is a string, and after you have a stream, and you put on it you are building a stream from the string, the empty string. after you are doing something about it, and this assertion is not executed. Why it is not executed? Because in fact, the programmer believes that the object on which the stream is working is magically mutated on string goals. So it means that here you have the result that is an empty string, and you are adding. The programmer thought that he was adding things in the stream, but in fact the result stays empty and it's not growing. So when at the end you are iterating on all element as string that is built from result, it is you are iterating an empty stream, so the iterator does not run, and so your assertion is not executed. So if you have an error somewhere, it's not executed and you can't see it, and your test is green. Another real but simplified one. So here it is in Java, so perhaps it is easier for you to understand. And the problem here is that sometimes get log entries return an empty collection. So once again, it's the same problem when you will iterating on this collection to assert some things. The iteration will be, the collection is empty, so the assertion is not executed. So what is important to understand is that rotten green tests are not intentional, meaning that they have assertion. So normally we will say, because it's not always the case, but normally assertion, or at least one assertion, should be executed. And they should not be rotten. And so it is not the programmer fault. It's the fault of testing tools that do not report them. In fact, you have a test, and in fact, the rotten. Why we call it rotten green test? Because it's like when you have some fruits and you have a very beautiful apple, and so it looks good, but when you are starting to eat it, you can see that in fact it is rotten, and so it's bad. It's exactly the same idea that you can have with rotten green test, because it gives you a false sense of security. Personally, I try to do tests, and I really enjoy when the tests are green. You can hear me in the whole corridor, and I am uploading and things like that when at least the tests are green. But the problem with rotten green tests is that your tests are green, but in fact your assertions are not executing. So in fact, you can easily not notice that something is wrong. And so it's perhaps even worse than having a red test, because when you have a red test, you know that there is an issue, and if you want to throw it under the carpet, you can just put self-skip or skip the test. But in the case of a rotten green test, you can't do that because you don't know that they are rotten. And so before we did something on Pharo, so before we developed Doctor test in Pharo and RTJ in Java, no testing framework were reporting this kind of rotten test. And the purpose of this presentation is to introduce you to this concept. I will show you later that it's appear in FAO, but it's not only in FAO, it's appear also in Java and Python, but it's only the two other languages that we explored. And the idea is that if you are developing your own language, or if you are using another language, it normally each testing framework like JUnit or things like that, or PySets or whatever your framework, should report red and green test and put them in another color in order to let you know that something is not good. So a red and green test is, so just to remember, a red and green test is a test that is passing, so it is a green test. But it is a test that contains at least one assertion, and one or more assertion is not executed when the test runs. And we will see that it is mainly caused by conditional code not executing a branch or iteration over an empty collection. So how can we identify this kind of red and green test? So sorry. So let's put some vocabulary. And so in your test, you can have some helper, meaning that your assertion may, for example, not be directly in your test, but can be in an helper. And that can be so an helper is either a method that call an assertion, or it's a method that call another helper. And so we will have to identify this helper. And so here it's not the, so it's the helper that is not executed, and so this the assertion at the end of the slide that is not executed. And it's important to know which assertion is not executed. So we need to see, in, for example, in this test DEF, we have an invocation of bad helper and after an assertion, and so the bad helper is called a second helper, and this one is not as an assertion. And it's important in the test itself to know which assertion is not executed, because it will help us after to see to find the bug if there is one. So obviously the self-assert true is executed, but in fact the second one is not asserted. So we need to identify the helper and to know exactly which assertion are executed or not. And so to identify red and green test, we need to use both static analysis to identify the helpers and inherited method, and dynamic analysis to identify the call sites that are not executed. So just one point to come back on the helper. I don't know if you are familiar with helper or inherited method when you are doing writing your test, but so the helper helps you to reuse some part of the test, and it's like when you do an extract method for traditional code. It's exactly the same in the context of test, when you can share on several tests some parts. So what do we do with the static analysis? So first we identify the testing primitives. So like in FAO, assert or deny, or in Java, the assert, assert equals, and so on. And we identify the helper method. And after doing the dynamic analysis, we use instrumentation. So we instrument the call site of the test primitives that we identify through a static analysis, and we run the test. And we obviously, as I said, that a red and green test is green. We record the green test, and for them we record the test primitives that are not executed, and we generate at the end a report. So before the execution, we first identify the helpers. So as I said to you, a helper is either a method that calls directly an assertion. So the last one is second helper is a helper, and bad helper is a helper because it is calling another helper. So so we have identified the helper, and so we identify also the assertion. We have one at the beginning in the test method, and we have one in the second helper. And so we put a spy on them, and we execute the test. And at the execution, we can see that only the first one is executed, and so the last one is not. So it is a rotten green test because of its first assertion. So we identify some categorization, and I will come back later on it. So we have some missing fail, missing script, context-dependent logic, and fully rotten. And I will come back on this different definition with example just after. But in the XC paper, so we provided the algorithm to identify the test. We provided the categorization, and we made a case study on different different papers on different tests. Sorry, it seems that it's not the last version, but it's okay. I will do with this. So we have made a case study on some tests in FAO, and we have we went through around 20,000 tests on major projects. So you have a small description of the different project with the number of so the project, the description of the project, the number of package, the number of classes, the number of tests, the number of test classes. Strange. No, it should be test method. There should be an error between the two columns, because otherwise it doesn't went well. And we have the number of helper, and we find for each category of rotten test, we find we put the number of them that we found. And as you can see, we found some fully written, and I will show you some examples. And what is also important to see is that we found, so for example, here we have the collection, so it's a library of collection, and as you can see, we have found some written tests. So it was really important to do this this analysis, because it is at the core of the language, and as you can see, we found a lot of written tests, not in all projects, obviously, but in some of them. So if we go back on each categories, so it's definitively not a good one, sorry. Yes, I will just go. Yes, sorry. I have an issue. Sorry. Oh. Sorry for this interruption. Yes. Okay. Yes. I will come back here. Sorry. Sorry, just before the categorization, I will explain to you how we identify. So as I said to you, I explained to you just before how we identify the rotten green test in general, but after we had to implement it for each language, and so it was like this that we did it in FAO and in Java. We were using the JUnit testing framework, and we identify the assertion primitive exactly as I said before, using static method invocation with names that with the keyword assert, and the class of the invocation is JUnit assert class. We identify the helper method, as I said, as a method with body containing an assertion or an invocation to an method. We instrumented the call site and we executed the test. And for the execution of the test, we compare between the line of code executed and the line of code that were not executed. In Python, it was a little bit more complex because Python has two specificities. The first one is, as you know, it is but like FAO dynamically typed, so it's more complicated to know exactly which method is exactly executed. And the second issue was that in Python, you can put your helper in a different module, and so it's more complex to have the information. So we were working on Unitest and PyTest frameworks. We identify and instrument the call site directly first at the beginning. So in the AST of the test, each method's call is instrumented with a meta behavior, and that spread itself at runtime and identify also the assertion primitive. We executed the test, and after we can identify the assertion primitive. It's not the same way when it is Unitest or PySet. and after we identify dynamically the helper and compute the report. So I'll come back to the categorization. So the missing fail. So it's a test that passes false to an assert method instead of using fail. And so this assertion should be executed only if something goes wrong in the test. So here you have an example of a Java project. So a Java test extracted from the project reflect as, and the assertion in red is not executed. And in fact, it is what the developer wants, because normally the exception should be caught, and so we should not arrive at this point. And but here, depending on the definition of the rotten green test, this test is green, it is passing, and there is an assertion that is not executed. And so how we can solve this missing fail? So we can check, we can go through all the tests that pass false to assert and do a case-by-case basis, but we can use fail to really indicate that the assertion should not be executed. The misskip, so the test contains guard to stop its execution early under certain conditions instead of using skip. So for example, here in another project, Java project, so it is the Apache Flink project, you have a return. And so if you enter in this condition, if the condition is true, you will enter in this branch and it will return. And so you will stop the process and all the assertions that are below won't be executed. So once again, it is a rotten green test. So how we can solve this problem? So we can find them by looking for tests containing guard to stop its execution early instead of using skip. And so, so for example, the tests that have returned in their branch. And so it's easy to fix. You use self skip or the equivalent. So self skip is in Java, but you have sorry, it's in Pharo, but you can use the equivalent in Java or Python. So the third one is context-dependent logic. So it's a complex logic with different assertions in different branches, and some may be rotten too. The fact is that when you have an if and an else, obviously, and an assertion in both branches, obviously one won't be executed. So so it will be a rotten test. And so here in this example, we have two assertions that may be in some case not executed. So this one, it's perhaps more difficult to fix, but perhaps the idea is to create a separate test for each branch and use skip to execute the test only when it's applied. And the last one is the more dangerous one, is the one that are fully rotten, meaning that there is really an issue. So what is the problem in this Python? Yes. So in fact, here, this one is, you have a, it's a skip. There is a problem with a skip, but yes, because in fact, web key was always true, so it was so the assertion were never executed. And so this one, yes, I don't remember this one, but in this one, and we will come back later on it. In fact, it was something a little bit strange, because it was the combine method was dynamically rewritten, and the self-denial was disappear in the new version of the method, and so it was an error in the way the compiler dynamically rewrites the method. And so for the fully written, you have a case-by-case analysis and repair. So we made an evaluation. So as I say to you, we made first an evaluation on Pharo, and after we replicate it in other languages, so Java and Python. And so we had three research questions. The first one was, do rotten grid tests exist in languages other than Pharo? The second one was, do we find the same categories of rotten grid tests as in the original paper? The third one was, do rotten grid tests hide bugs in the program or only in the tests? And so we selected around 100 projects per language, so Java and Python. Projects were available on GitHub, and we wanted to find popular but also representative of project of the language or the community. So for this, we put some criteria, at least a push after the 1st January 2019, and we compute a score. And we ordered the score depending on the merge pull request and the close issue, the number of fork and the number of star, in order to have an idea of the activity on this project, and not only to focus on the star or the fork. And we ordered this project. And we took the 100 first, but almost like this. So we had extra criteria for Pharo. We relaxed the date because otherwise, because the Pharo community is smaller, and so we need otherwise it was too small. We need a version after 2015. We need a continuous integration in order to facilitate the way we can take the version of the project, and the test can be run locally and all are passing. In Java, we get only 67 projects, and we wanted also that the project use JUnit 4.x as testing framework and Maven as dependency manager system, and in Python it was PyTest or Unitest as testing framework and existence of the setup.py file. And so for the first and the second, we got this result. So you have so in the first column you have the language, and after you have 2 columns per type of rotten green test, and you have the number of tests and the number of projects. And as you can see, we find for each language and for each kind of rotten green test, we find some project in Java, Pharo, and Python that contains them. and not only in one project, but in several and in the 3 languages. To answer the last research question concerning the bug, so I briefly say to you in Faro we found one. There was an error in the way the compile method was dynamically rewritten by the compiler, and we also found in Python in the Junja 2 project. So it seems that normally it is a lot used. In fact, so this test ensures that if a template contains more than one extent, a dedicated template error is raised. But there is an error here. So normally you should use else branch or PyTest raise context manager. And if you modify it manually, the code turns red. So meaning that there is an error, and this error has been discovered and corrected some months later. So as a conclusion, and sorry to have been so long, so red and green test exist. We believe that every unit test framework should report them. Doctor tests, the new Faro unit framework reports them. We develop also a tool in Java to report them. We replicated the experiment on Java and Python, and we found many red and green tests in the 3 languages. The categories are the same, and sometimes we didn't find bugs in Java project, but it's not because we didn't find that there is no. As I said, we only explored 67 projects, and but it's great that there is no bug hidden by red and green tests in every project. So thank you for your attention. Sorry for the little issue in the middle, and I can answer your question.
Thank you very much, Anne. There was a lot of reaction to your lovely presentation on Discord channels, and I have a list here from Eleni with many questions actually. So if you're ready, let's take the floor. Thanks again for the keynote. It was very good, and was the first one, and I think it went okay. So yay for that. So we have a first question from Csaba. He's asking whether you can imagine situations when a tester could justify the presence of a rotten test. So the assert is there by intention, and it really depends on the context whether it should be executed. So I think that this touches a bit on the type of rotten test that you described, the context one.
Yes.
Is there more that you could gauge from the code, something extra to add there, more context types?
Yes. So as I said, the problem with rotten green test is that you have an assertion that is not executed. But it's true that in the category that we call the context dependent category, it's obvious that in some case it won't be an assertion won't be applied. So it depends how you want to do your test, but there is 2 possibilities. Either you can decompose your test in smaller unit tests in order to test separately each branch, and like that, each test corresponds to only one branch, and normally you should not have red and green test. Exactly. The second thing is that you don't want to do that, but perhaps what should be good is that your unit test framework say to you that be careful, one assertion has not been executed. And so like that, for example, if in each branch you use a different a different method, so your test will go through only one branch and not of all the branch. And like that, you will know that even if your method is covered by a test, perhaps it is not executed.
Right. Yep. Sounds good. I'd like to go to a question by Eleni. She was wondering if there are some possible strategies to limit rotten tests without increasing the maintenance effort for the test code, of course.
So one of the skip and things like that, but can be dynamic, can be automatically modified. So you can remove a return or if false, because like that, if your test framework reports the rotten green test, this one won't make noise, and you can focus on the other one. And so if you can automatically modify this one, like this, you will, and I think after, yes, it is habits that we need as developer or tester to take. Make perhaps smaller tests. So it's already good if we do test. It's the first step, but but the second one is perhaps in case of unit tests to do smaller tests. It's obvious that in the case of integration or other kind of tests, you will have bigger tests. But in the case of unit tests, it can be great to have smaller, and like this, when your test is green, you know for real that it is passing, because you know now after this study, now when we have a test green, we say, is it really green or is it a rotten one? And so it's the worst thing that we can have. So if you don't report it, it's really difficult. So yes, if you avoid the noise, remove the noise like this, it will be easier for the maintenance guy to focus on the ones that really need them.
Yeah, nice. And then I think we still have time for a quick one, which is a nice subject as well to take into the break as a more philosophical debate. Why are they called? So Kim Mens is asking, why are they called rotten and not just dead tests? Because it's simply a test that is never really executed, just like dead code.
In fact, there was a big discussion on the name, and and the idea of Stefan that found the name was really this idea of the fruit. It's really beautiful outside, and so it's a green test, and it's beautiful because it is working. Normally a green test, it's a good thing, but when you eat it, it is working. And so it's really this idea, and because he was the chief, he won. So it is this this name that kept.
Indeed. Okay, then I think we are. I've got some more questions. If there's still some time, we are precisely on the dot. I could still go through the questions that we got from everyone, and we can also use those as discussion points for the break as well. We also from Kim. He was wondering if there's the classification of the types of rotten green tests. You already mentioned those, and I was wondering as well if you could link maybe the types of projects that you analyzed with the type of rotten tests that mostly occurred in the projects to see whether there was a link there as well. Then we have a question from And then Kim also was wondering if, apart from conditional statements and loops, if there's anything else that could hide such rotten green tests. As far as you know, could be another topic of discussion. Alexander was wondering if it seems that projects have preference for a specific category of rotten tests, right? So it was that kind of connection.
Yeah.
Is it related to a small group of developers making the same mistake over and over again, or to code being copied from different parts of the system? So basically, yet another effect of cloning. Then Andrei Agaronian was wondering whether it could be that some of the bugs in tests are introduced intentionally by developers to hide small bugs in the system itself. So that, yeah, that's going to be difficult to gauge. And finally,
Self-skip, put skip on your test if you want to hide something, but not like that.
Yeah. So hide it in plain sight, basically. And then if you would have a good classification of types of rotten tests, you could make dedicated analysis and resolution strategies, but probably that's also for later in the research as well, not only in the presentation. So sort of an actionability plan. This was from Kim again.
Okay.
So anything that you would like to add from these topics of discussion?
Just yes, the fourth point was we found this point and we wanted to share it with the community, and that was the first paper that was published in ICSI, and we discovered it in FAO. And the second thing was, is it only on FAO? We thought that it was on other language, and we did it in we replicated on Java and Python. But I agree we can go further, but the first most important message was that it exists in other language, so modify your test unit framework in order to report them. And it's true that now we can do a lot of studies on effectively if it is the same authors that do always the same type of rotten green test or not, and if there's a correlation and so on. But in fact, now you can ask me the question, but before my presentation or before, I don't know if you attended ICSI 2019 and perhaps you already saw the presentation by Stefan, but before our paper, we even didn't know that it exists. So it's true that now you can have a lot of idea to do things, but our most important things was to aware you that it exists. And we should perhaps continue things on this point, yes.
Very nice, and a very nice message to end the keynote. Indeed, a seminal work, really nice, scratching the surface to something that's now to be explored, and there's a whole field to emerge from there, I think. It's really cool, a whole area of interest and research. I'd like to thank again Anne, overcoming technical difficulties and giving us a really nice keynote. And with that, I would like to invite everyone to our Discord lobby, and from there to find the coffee table, the Keynote voice channel. They're all in there. So perhaps Eleni, you could share the
So as you might have noticed, now we have quite a big break. It's supposed to be our lunch break, so we have until for 40 more minutes. So grab a sandwich. If you have lunch ready, grab your lunch and some coffee. And let's meet at Discord and let's join the channels. You can join the voice channels there, where you can also turn on your video if you'd like, and we can already chat there in groups all together. It depends how we decide to distribute ourselves throughout the channels. And then let's be back.
Wait. One question. Where do you want? I can go in a coffee table and discuss with the one that wanted.
Okay, so let me do a small demo. Let me share.
No, just to say to me in which table you want that I go.
To discuss for the keynote.
Because there is a table per each
paper. Yeah.
Each paper, but not for the keynote.
So our amazing organizing team will create now one special coffee table called Keynote One. So we will do this now,
Okay.
and
It's
yeah,
there. It's there. Look.
it's there already.
Keynote one.
Keynote One,
Ah,
yeah.
yeah.
So
Okay,
yeah,
great. I will
so
be there.
let's continue the discussion for the keynote there, and see you all back here on Zoom in 39 minutes.
Okay, thanks. Bye.
Okay.
Kim is already in the Keynote voice channel. So
Yeah, let's go there.
let's grab some lunch and go there. Very nice.
Yeah, great. See you there.
The Zoom link is going to stay open, but I will just close my mic and video for now.
Me
Uh,
as well.
don't forget that in Discord you can also share your screen, share multiple screens if you want to go over details. So it's pretty neat. We can make a lot of use of technology. Thank you, everyone, and see you soon. Bye.
Bye. Welcome back, everybody. So I hope you enjoyed your lunch or coffee. So we will continue now with the hackathon intro. So I give the floor to Miroslav so that he can share his screen and start the presentation. So please remember the hackathon channel on Discord, where you can either type your questions there during the hackathon presentation, and then we will dedicate quite some time afterwards for question answering here on Zoom as well. And we'll see, I mean, if any questions pop up during the discussion, then we can allow here, of course, live questions here on Zoom afterwards. But first, we'll start with the ones on Discord. So Miroslav, the floor is yours.
Okay, thank you. Thank you very much for this introduction. I'm Miroslav Živković. I work for a company called Software Improvement Group. And we have agreed with the chairs to provide the data and assignments for this year's edition of SATToSE Hackathon. The data and assignments will be within the scope on the Horizon 2020 project that is called FASN. And FASN stands for Fine-Grained Analysis of Software Ecosystems as Networks. This presentation will actually have three connected parts. In first part, I will try to talk a little bit about the FASN project. In the second part, I will talk about the role that SAG as a company has within the FASN project and what do we do. And in the third and final part, I will focus on exclusively on the hackathon. I will describe the data, and we'll talk about the assignments and some organizational things. So let us start. Okay. So the FASN has software ecosystems as a playground. And we all know that the open source software today is a very common thing, and the reuse of software libraries, packages, and such is speeding up the development efforts. The ecosystem grows by itself, and here are some figures that are pretty outdated, I would say. But the keywords here are that we have these ecosystems organized in the networks of interdependent packages, and that dependencies are actually, I would say, the main issue and main concern within these ecosystems. And FASN as a project focuses on the dependencies. We do not explore direct dependencies only. We are really concerned with all types of dependencies that would include also the transitive dependencies. Why are dependencies could be such a nasty thing? This is just one of the examples that I am pretty sure you're fully aware of from the March of 2016. There was a dispute about left pad. And left pad is just 11 lines of JavaScript code. And because of the dispute of the name, the owner of the left pad decided to unpublish the package. The consequence, because of the dependencies, direct and transitive ones, was that the web was basically brought down for a relatively long period of time, and that many websites were actually affected by this. So of course, the problem of dependencies, interdependencies, transitive dependencies, so on, has been a very rich area for the research in the previous years. And here are some conclusions, very general ones, that could be drawn from all this research that has been done. First of all, there are a lot of vulnerabilities that are just waiting to be exploited and to propagate through the dependencies in the ecosystem. The developers, as we have seen in the left pad example, also use very often some micro packages, very trivial ones, with lines of code that is less than or equal to 35. And why is that? Because the reasoning is that these micro packages have been thoroughly tested and are very well known and widely used and so on. One of the challenges for the ecosystems is that the developers are not that agile when it comes to updating the dependencies. And one of the reasons, and that has been mentioned by the developers themselves, is that they actually fear that the code would be broken if they, move to the or use the newly released dependency package. What are then the challenges that we try to tackle within the FASN project? So we want to look into the impact of versions, the license compliance, the maintenance, the reliability of the libraries, the performance, and so on. We want also to help the developers and practitioners to decide when and which packages to adopt, which packages to update, which packages to replace, and so on. So these problems have, and this motivation of the FASN has helped us to come up with the project proposal and the project itself. And one of the key components of the project is actually the fine-grained analysis of the dependencies we have. And what do I mean by that? We have the state-of-the-art dependency analysis that is more or less based on package dependencies graphs. In reality, and what is more fine-grained, and as we have the different levels of aggregations, we could say that the much better insight into the problem and the analysis of the problem could be gained when the actual call graphs or function calls graphs are made. So some of the initial questions that we have in the FASN project is actually whether the particular vulnerability would affect the code that I'm making. What about the licenses? If I use the GPL license, how many clients would be affected if I change these dependencies? Can I safely update, and so on? As I said, the core idea of the FASN project is the creation of an ecosystem-wide fine-grained call graphs. And these call graphs are based really at the functional level of aggregation. That would allow us to develop the fine-grained tracking of dependencies for the existing dependencies networks. And we will actually add some intelligence on the top of maintaining and managing the software ecosystems. Of course, the challenge here would be how to scale up with this, because there are really millions and millions of packages to be maintained, and the graphs could be enormous with respect to the number of nodes and edges. Also, the FASN project has focus on analysis of security vulnerability propagation, licensing complying and monitoring, and the dependency risk profiling. This picture at this slide represents the initial setup of the FASN tooling, and you can see that we have focused on package repositories for Java and Python, and recently we have included also C. Based on the package repository is of course used to generate or construct the call graphs and the fine-grained call graphs. This call graph construction coupled with external sources of information like the metadata, the project metadata, like the vulnerability databases and so on, is used by the analysis layer of the FASN. And here we do the analysis of security, license compliance, quality and risk, and change impact. So that is to answer some of the questions we have. For instance, how many packages will be impacted by the change of a particular library. And yet another layer of the FASN is a storage layer. As I have said, we have really to take care of storing billions, potentially billions of nodes and edges. And on top of that, we need to store the metadata, including probably the source codes, which will be used to analyze the quality and risk of the source codes of the analyzed software. Okay, so that was in a very general the FASN playground. There are really a lot of details here, so should you have any questions, I would like to hear them, and also the other participants of a FASN project that are here at the conference would be glad to answer you. A little bit about the SAG, because we are partner within the FASN project. Well, we actually do business that takes care of the quality of the source code. And we do our business by analyzing the source code and the methods. And we are very proud to say that we analyze weekly around 170 million of lines of code. So we have really a lot of experience in quality models of the software systems, the risk analysis, and so on. I would also stress that we are actively, next to doing the business in this area, we are actively contributing to the research, and we are participant, as you have seen, of a number of research projects. Besides, we are also active in standardization and certification with respect to the quality of the software systems. So FASN at SAG, these are the partners within the consortium. SAG is, which is not a surprise, doing work with respect to the quality and risk analysis at FASN. And here you can see the members of the team, with Michiel being also the head of the research at the company. What is, on the other hand, SAG doing at FASN? So we focus on identification of quality characteristics and the risks. We, of course, do that, perform the code analysis. And we also aim to, by doing this fine-grained analysis of the call graphs, to gain additional insights and improve the accuracy of our models and the decisions that we base on these models. Okay, so here is an example, a typical example that we consider within the FASN project. So let us assume that we have a vulnerable, we have a software vulnerability. In this particular case, we have the SQL injection vulnerability, and that we also have a direct dependencies that are simply exploited by this vulnerability, as they have called the method that is vulnerable. And because of the transitive dependencies, we see in the use case 1 that we have a propagation of the vulnerability through the packages. So with vulnerability, in case it is 0 or 1, either the package or method is vulnerable or not. And if it is vulnerable and calls the code that is already compromised, you know, the vulnerability would simply spread. Second case here is what the result of the fine-grained analysis. So there could be a package that is vulnerable, but the dependent code never uses a particular method. So then the vulnerability does not spread, which doesn't mean that this is not the case in the future developments of the code, that this could change, this could potentially change. So we need to take care of these cases. And the third and the best scenario is when actually we have the prevention of the propagation of the vulnerabilities, and therefore the vulnerability remains contained at its source. In other words, this is just the better illustration of the previous example. We could have a system that uses the libraries. We see here the direct dependencies, and at the very bottom we see the two transitive dependencies. And we see that the system uses the interface that is not compromised, and therefore there is no possibility of vulnerability propagation into our system. The compromised interface is simply not used, and without the fine-grained analysis that is performed in the FASN, this library at the bottom would be considered compromised and a threat for the system, and we see that is not so. What also we consider at the SAG within the FASN project is how to aggregate the metrics, the different metrics, and to come up with the model that would allow us to mix good and bad maintainability and come with the overall assessment of the risk within a particular system. And these are some parameters that we need to consider: the volume package, how do we compare the large packages and small, relatively small ones? How does the vulnerability or other quality parameters propagate when the packages are used? Then how to deal with the nesting and so on. And this is an example that illustrates this. So we have the model. We have two axes. One is the update effort. So how much effort is required to update a particular library. And the second one is actually the risk of that library. And we see that we start with the version 2.1, and as the time goes, we go to the 2. The risk becomes smaller and smaller. But when we have here with release 3.2 some anomaly, there is update with a serious risk, and immediately a new subversion is deployed, developed and deployed, and so on. So by looking at this figure, we could say that we have the area of the low risk packages or libraries, but that they require a high update effort. We also have the high risk and low update effort area, which we model into the overall moderate risk for the system. Naturally, we have the area of a high risk, high system risk, when we have the update that is really highly risky and requires a high update effort, and we want to come or to help the developers to come into this area of very low risk by suggesting which updates, which libraries needs to be updated, and the overall risk would be then reduced. Okay, so that was the SAG, and we have done our best to prepare the hackathon for the SATToSE. The hackathon data has been basically originating from the FASN project. There are two data sets that we have provided. There is a call graph set. So at this moment, we have over 1 million Java-based call graphs within our FASN environment, ready for the analysis. But for the purposes of this hackathon, we have selected a random sample of 5,000 Java static call graphs. Then we have the other set, and that's the dependency set. This set has been derived from the call graph set, and it contains a list of direct dependencies for every product version, and that is limited to a number of 10 dependencies. So that when there is a library version 0.9, we give you all the direct dependencies of that library. These two data sets are accompanied by a document that contains this information that I'm presenting now, but also a little bit more details, not that much more, but still more details. And it is a single password protected zip file. Where to get this file and which password to use will be provided to you at the Discord channel. And in case you have some questions, use this channel or just email at this email address at Gmail. Now, let us go a little bit more to describe the data sets. The call graph set is basically representing call graphs in a JSON format. It's approximately 3.5 gigabytes, and it is UTF-8 encoded. When you are trying to read this data set, please do not read it as a single JSON object, but read it line by line, and each line is one call graph and is one JSON object. And here is just an example of code that you might consider to use for reading this data set. The dependencies data set has 6 columns which are separated by tabs. Column names are given in this slide, so the first 4 apply to the package in question, and then we have the last 2 are applied to the dependency. For the package, you will see the ID, which is a number assigned to it, the package name, the version, and when it was created. And for the dependencies, we have just the dependency ID and the name of the package. Please note that per version, we could have a maximum of 10 dependency packages. That has been kept in order to keep the data relatively small. Now a little bit more about the JSON format that is used for the call graph information. So as I have said, you will have 5,000 lines. You have to read a line by line, and the single line is more or less like this. So first you have, of course, the name of the software library. Then you have the forge, and the generator is a call graph generator. I think for the data you have, it is Opal. Then we have a list of dependencies for this software library. It is again starting with the name, the forge, and the constraints. The constraints are actually representing the set of the revisions of this dependency that could be used with this version of the software library. What then follows is a class hierarchy analysis result, and it is like this. First, we have a fasten URI of a class as a key. This is actually the map. So the key is fasten URI, and then we have the associated type, and the type contains all this information, and that is a map of methods that is implemented in the given class. Of course, this is the method ID, that's integer, and then we have the method in canonical form. We, of course, have the super interfaces of this class, the source file name, and the super class, actually the list of classes that this type inherits from. And that's in the order of instantiation. Then after this, we have a description of the graph. We have the internal calls. Internal calls is simply a list, as we see here, a single element with the source method and then the target method. When it's internal call, of course, all the methods that are listed here should be also present here in the list of methods. For the external calls, we have again the source. So the external calls are calls for instance, from a method in this class to the method outside the class. And we have here some metadata information describing or how to say, helping us to understand a little bit more about the outside method. And the last but not least information that you can find in JSON file is a timestamp, and that is Unix format. Okay, now the assignments. Well, you could see them at the document that you will download, but we have thought of two assignments. First one would be to establish the most popular method from the packages, and the second one is to investigate the version evolution of the product. So here are some ideas which you can find, which methods are the most used by the packages, what are the most popular packages. You could look for the most popular methods of certain packages. Now, then you can see, for this example, the number of calls for a particular method, and then do the distribution if there's 5, 10, or whatever. For the version evolution, you could look for the maybe frequency of the updates, look for the anomalies in that frequency updates. For instance, if the package was released today, and then you would expect the next release to be in 6 months, but it was the new release was 2 days after. That is an anomaly, so you could look for that. You could look also for the number of dependencies and distribution of the usage. For instance, how many dependencies are used per product, and so on. Of course, these are just the ideas to make you start to think about what you can do with this data. You can come up with your own idea, and that would be very much appreciated by the hackathon organizers. The deadline for submitting your results is tomorrow at 14:30 UTC. The notifications when you are ready to submit or you have questions, of course, at the Discord channel or send an email. And I can only wish you a good luck with the hackathon and looking forward to your submissions. So that ends my presentation.
Thank
you,
you.
Miroslav. Oh, Anna, take it.
Okay, welcome.
Thank you very, very much. Are there already maybe questions for Miroslav? If so, please raise your hand. Otherwise, we can go towards the break, and then you can take advantage of that to directly approach Miroslav in the voice channels, just for simplicity. I would like to also encourage everyone in coming the next sessions, especially the presenters, to quickly drop me a hi on Discord so I can make them co-hosts so we can seamlessly go into from one paper to another. I've seen that Csaba was already very active collecting all his presenters for his session, so that should go smoothly already. If there is not anything else, then we should go to the break. We are already, I think, a bit over time. Let me check the minutes.
We're good with time. We're good.
We're good with time. Yes.
Yeah.
So we could just go into the break rooms earlier and see if people have already questions about the hackathon, which looks really promising and exciting things there. And Nuria and Miroslav will be available for questions for everyone. That's it on my side. Eleni, anything that you wanted to add?
No, just be on time for your session if you're in the next paper session. You should all have co-host right now provided by Anna. And let's chat until for 30 more minutes on Discord and get back here then for the first paper session.
Yes, first paper session starts at 11:45 UTC. And we're looking forward to resuming. Good. Then have a good break.
See you at Discord.
See you at Discord. Bye.
Hello, everyone, and welcome back for the first paper session. So I will give the floor in 1 minute to our session chair, Csaba. What I would like to remind everyone is to ask questions on the Discord channel. So there's a session 1 legacy microservices channel. We ask the questions there during the presentation, and then the session chair will communicate this here. And I would let Csaba explain more details on how things will work for this session. So please ask questions, use emojis to like the questions to ask them first. So I'm going to give the floor to Csaba.
Okay, so welcome everyone. I just quickly introduce myself. So I am Csaba from the Software Institute di Lugano, and I am very pleased to be the session chair of the first session of the first virtual SATToSE. And I'm pretty sure that this is going to be a very cool session with interesting talks. So the topic is legacy and microservices. And the first talk is, I think, recorded. And my supporting student volunteer, Quentin, is ready to play that for you. So it's from Wouter, and it's about model-based fuzzing using symbolic transition systems. And I think we can start with the talk. Let's start.
Hello. My thesis is about model-based fuzzing using symbolic transition systems. Model-based testing, MBT, is an up-and-coming technique for automated testing. Rather than writing unit tests by hand for every scenario, one can generate tests from a formal specification model. This model covers partial or full behavior of the system under test, SUT. Based on this model, test cases can be generated using different strategies. The goal is to reach a high model coverage and thus proving that the system behaves like it should in all specified scenarios. One way of expressing models is using symbolic transition systems, STS. With STS, we define behavior through transitions containing labels and values. Labels contain a data type and can contain constraints. While MBT is a functional testing technique, non-functional security tests are not covered with this approach. Therefore, our goal is to combine it with fuzzing. So what is fuzzing? It's an automated testing technique that provides unexpected or invalid input to a system under test that cannot easily be found by hand or functional tests. Then we monitor this software for unexpected behavior and finally analyze the logs. Fuzzing is mostly used to find obvious bugs like memory leaks or edge cases. Fuzzers are often categorized on program awareness, input awareness, and input seeds. So first, program awareness. Black box fuzzer has no knowledge of the source code, while white box fuzzers perform program analysis. Gray box fuzzers are something in between. It does not perform analysis, but it can track when a new code path is reached and use this information in concurrent cycles. Then input awareness can be dumb when the fuzzer has no knowledge of the input structure. Dumb fuzzers supply random inputs or generated inputs by some general algorithm. Smart fuzzers, however, have knowledge of the input structure, often through grammars, and can generate or manipulate input according to this. Input seeds can either be mutated based on valid inputs or generated from scratch. This requires the fuzzer to be smart. In order to find a suitable fuzzer we conducted a systematic literature survey. We searched the following scientific sources as well as GitHub repositories. We found a couple of systematic reviews on fuzzers in general, as well as papers presenting a new fuzzer. The systematic reviews we found were all more than a year old and only covers scientific sources and not GitHub repositories. Most surveys covered a large amount of fuzzers that are incompatible with MBT. In order to filter the results, we applied the following filters. It should be general purpose and allow complex input structures. The most widely used state-of-the-art fuzzer is AFL. It's a general purpose, coverage guided, mutational gray box fuzzer. One can supply files or texts which are then mutated. Since AFL is one of the most advanced fuzzers out there, it is widely extended in an attempt to solve specific use cases, or it is combined with other techniques. Furthermore, AFL supports dictionaries, which is basically a list of keywords that the system under test accepts. For instance, in case of an SQL database program, it can be insert, delete, select, whatever. The first step we took was implementing an AFL wrapper that can communicate with the Axini MBT toolset. This way we have a generic implementation that works on all SUTs. We created a dictionary generator that extracts label values and puts them in a dictionary file. We found that coverage guidance cannot always be guaranteed. Some SUTs use an adapter to communicate with another process. In this case, we cannot monitor the code paths it took, and therefore AFL turns into a black box fuzzer because we cannot monitor new paths that are reached. And it only fuzzes the adapter itself instead of the software. Unfortunately, we have not found any significant results yet using a dictionary generator over the default implementation without a dictionary. Our next step is to implement a grammar-based fuzzer. Our goal is to convert model information into a grammar, which can then be used to generate semi-valid inputs. In our literature survey, we found 4 candidate fuzzers that can be compatible with MBT. Peach is a black box fuzzer that uses XML configuration files to describe the input structure and the way the target will be fuzzed. AFL Smart is an extension of AFL that uses Peach to generate new input seeds, thus combining the best of both techniques, complex input structures and coverage guidance. Then we have yet another AFL based fuzzer, Nautilus. This fuzzer makes use of grammars defined in Python files and adds this as a mutation strategy. Last but not least, Superior. Similar to Nautilus, it adds a mutation strategy, but then uses Antler and constructs an abstract syntax tree and then randomly mutates the input.
Okay, so I think the presentation is over. So let's look at the questions. Okay, so I would like to encourage everyone who is interested and wants to discuss, ask questions. At the moment, we haven't received questions yet. So I just want to ask something, and in the meantime, if somebody has something in mind, feel free to write it. So I think I miss the context a little bit because so for fuzzers, testing can be like a programming language, a grammar, or even a network protocol. So I'm curious, what is your targeted source for this?
Basically, it's targeted on anything that uses a model. It doesn't really matter what the SUT is, as long as we have model information to supply it to a fuzzer. Because the fuzzer I mentioned, American Fuzzy Lab, is general purpose fuzzer and can be used for anything really. So network protocols or even operating systems, anything really. So the whole context of the of my thesis is pretty large. Like I try to cover everything.
Okay, I see that Kim-Mans has a reaction for this. Kim, can you unmute yourself, or I can ask you to?
Yeah, so I would like to add to the remark that Csaba just made. I don't agree that the model doesn't matter. If you would have a different application domain or domain on which you focus, or a different model from which you get the data, you target your fuzzer and make a better or more appropriate fuzzer for that particular domain or for that particular model. So I think the question was really pertinent. What is your opinion about that? And did you find things like that in related work, that you have fuzzer specific for a particular domain or for particular models that you analyze?
Yeah, so basically there are a lot of fuzzers out there, indeed, and some of them are really specific to some targets, and a lot of fuzzers also extend American Fuzzy Lab. So those fuzzers are really specific. But the one I use now, just American Fuzzy Lab, is basically pretty has a large amount of target software that can be fuzzed. So yeah.
Okay, I think yeah, it's a good point. So how do you test it? So if you say that it's very general, I guess you have something targeted that you test it on.
Yeah, we can compare it to black box baseline. For instance, if you use American Fuzzy Lab without a dictionary or anything, and we let it fuzz for, I don't know, 24 hours, then we can measure how many errors it found and compare that with those results to better version of it by using a dictionary or smart input values. So then we have a comparison of the efficiency and the effectiveness of our approach. So that's yeah.
Okay, so this is mostly conceptual at the moment, right? So it's I see that it's a work in progress. So if it's a work in progress, where are you like in the development?
At the very beginning, to be honest, because I had to look into a lot of surveys and research, and I composed a list of fuzzers, and I compared their characteristics, and then I filtered them on if they would be compatible with MBT at all, and then I started implementing a few fuzzers, and then I stumbled upon a few issues, and it's basically at the beginning of my whole research. But currently I'm looking into Peach and AFL Smart, and I got those to work. So now I'm trying to figure out how to combine that with the MBT toolset. And once I have that, then the whole research is started, basically, the whole comparison and implementation of it. So yeah.
Okay. Okay, so we are still waiting for questions. If somebody has anything in mind, feel free to ask or give feedback or guidance where to go on with the work and how to support it. So I have one more question in mind. So I remember somewhere in the paper you had a research question. I think it was the third research question. Where you said, I'm just looking at it again. Yeah, so it's how many person hours can be saved by combining STS with fuzzing?
Yeah.
I think it's a very nice research question. I'm just curious that how do you plan to address it? Because for that I couldn't read anything in the paper.
Yeah, so what I mean with that is how much time can be saved by automatically generating input data for the fuzzer instead of writing the whole configuration file by hand. So for every single SUT, because that's the ultimate goal, that you don't have to write the whole input structure by hand, but you can generate it based on the model. So yeah, that's what I want to measure it.
And what is your impression? How much work is it to write the whole configuration? I mean, just without your approach. So how much time could be like in theory scale?
Sorry?
So what is your impression that is it a huge effort writing the configuration so it can be measured in like days or weeks, or
yeah, depends on the SUT and how complicated the whole model is. If it's a very big model, then you would spend a lot of time creating an input structure file, and because you do it by hand, you can also make mistakes by doing it. So yeah, that's the point of the of this.
Okay. So I think we have 1 minute left. I'm basically done with my questions. And if still somebody has something, raise your hand. Otherwise, I think we can prepare for the next presentation. And of course, I guess Wutebi is still available in the lounge area next to the coffee table, so we can still talk to him after. Okay, so Celine, are you prepared and ready for the presentation?
I am. I need to understand how to activate the camera. There it is. Yay! And frame the thing. Yay! Perfect. It's my first Zoom thingy, so please excuse me if I misdo some of the things.
I guess it's the first for many of us. So.
Yeah. So you should see the slides, right?
Yes, it's visible here.
Okay.
So,
perfect. Then I can start. Okay. So hello everyone. I'm Celine Knop, a PhD student at UC Louvain. I'll be presenting our paper on advanced differencing of legacy code and migration logs. First thing, I want to talk about what is code differencing today. So on the left side, you can see a screen of a random GitHub commit. So most of you have seen that and interact with those things regularly. And actually, the original algorithm was created by the Etien and McIlroy in 1976. And since, it hasn't evolved much. Yes, we have new formats and new UI standards, but the algorithm itself hasn't changed. And such a diff is sometimes hard to interpret. They can be very long. They also are file-based, which means that when you have changes on object or something, it's hard to interpret. And actually, they don't use the semantic at all. They consider code as just bit of text that hasn't especially rules and things like that. So analyzing diff is actually pretty tedious when you try to do it extensively. In our project, we want to advance code differencing with actually very concrete case studies in mind, because we are working with the company Raincode Labs. They work in software modernization, and in this case, we're interested in a project that they do that is pack-based migration. So the workflow of pack-based migration is something like the schema that you have here. Actually, pack-based is a tool that is no longer supported, so it needs to be retired, and it generates COBOL. But as many tools that generate code, it generates really bad COBOL. And so Raincode apply transformation rule, which can be considered as small refactors to make that COBOL better and more easy to maintain. And in the process, they also create logs, which are an artifact of interest because we will be using them in our research. The first step when doing this kind of project is to actually choose and pick the transformation role, because that process is targeted to every client. So that is the first step. Then the second step is to run the migration a first time, because it's really important for the clients to be sure that what they get is working, has the exact same functionality, because that code will go in production. So it needs to be tested. And then simply the entire code base is migrated and delivered to clients. So what we did, yeah, so this is the kind of things that you could expect from giving bad COBOL to the left to Raincode. You could expect to get better COBOL that you can see on the right. Actually, all those go-to can be translated to a simple loop with an if-else condition in the middle. Now, in our research, we wanted to analyze this process to find where manual work was done at Raincode and to find where advanced code diffing could help them. We did so, and we find that manual work is mostly done in the redelivery process. First, what is the redelivery process? Well, when the client gives the code base to Raincode, they have a version, let's call it X from the code base. It generates version X of COBOL code. And then Well, work happens. Raincode does the migration, but at the same time, since this is production active code, well, the client keeps working on that code base. And by the time Raincode is done with the migration, there is a new version called X+1. That new version may have new feature or bug fixes that need, well, to be integrated in the migrated COBOL to be able to have all of the things in production. How do we integrate the changes? Doing some kind of taking the change in the generating COBOL, etc., is too complicated. So simply the migration is run again. But then a question arises. Does that new VX+1 COBOL, it hasn't been tested by the client. Is it safe to go in production? What changed? Why did it change? All of those questions, Raincode need to answer them. And to do that, they do a manual analysis. But yeah, and they do that manual analysis using diffs and log of the migration process mostly. But this is a time-sensitive matter, because if they take too much time for the manual analysis, well, a new version will appear and they'll have to start over. That creates actually a communication problem. The engineers at Raincode are doing this since 15 years or something, so they do it like quick and dirty. They have instinct, they have previous experience, but that means that the client does not receive a full detailed explanation. And sometimes when, for example, they say that the client needs to retest some of the things, since that's a costly process, he doesn't want to, and then haggling start, and then more time is lost, and maybe a new version appears. So what we want to do is to help Raincode engineer explain to their client easy things like where the code has or hasn't changed, how it changed, and why it changed. Because when you're using tool to generate code, actually, you might not always understand that having a small change in the tool that you use to generate the code may lead to big difference in the generated code. So to do that, we choose two approaches that we think can be interesting. The first one is using reduced flow graph that we want to use to explain how and where the code has changed. And we want to use as artifact the two migrated versions. So the migrated COBOL that will be put in production. We want to create simply a reduced flow graph of said COBOL. Here it's not COBOL, it's probably just pseudocode, but you get the idea. And from those graphs, in the paper presented by Lasky and Zensmer, they actually diff those graphs like you would do code, simply text, and they create the graph that you see all the way to the right, where code that hasn't changed is the same label as it was first, and node that contain code that has changed are abstracted by the node mod for modification. And you could see when you click on the node a diff that would be more concise. Hopefully, you could better see if you have that part that changed, part that didn't change, and what changed. That would be more visual. The second track that we took, and that's what we started actually, is to look at the logs. So on the right side of the picture, you can have an example of what a clean log looks like. This is a very simplified version of Raincode's log. This is what I'm working with currently to generate my log differencing. And these logs are composed of two interesting things. First, you have intermediate version, because when they do the process of migrating, they actually have intermediate version to save the code to be able to backtrack if necessary. And then you have the refactoring rules, simply learning. The idea was presented by Goldstein, Rad, and Segal in 2017. Simply, you want to construct an FSA representing the step of the process, the behavior of the process, and then diff those two FSAs to show here in the special line the new nodes or the change in probabilities. And that probably would give Raincode engineer a way to explain why the thing has changed. So now I have actually early result. I started with that. This is a very shortened version of one of the graph that I generated from the log given by Raincode. And you can see that it's fairly linear. And then that's the second version. It's almost as linear, but you see that we can now loop between intermediate version and the else if thing. And actually, when you do the differencing, you can see that a new link was added and also the probability change. And actually, if you do the diff manually of those files, you would get probably 200 lines. If you do the diff of the log, it's already a bit better. But when you see an image like this, I personally believe it's already clear. So those are the two parts that we want to explore and our current progress for this specific path. Just to conclude, we want to use control flow graphs. That will be for the future, and also use the logs and create FSR to explain why things change. Thank you for your attention. And if you have questions, I'll now be able to answer them. And I'll get Zoom back so I can see people. Thank you.
Okay, thank you very much for the presentation. I think you have a very nice topic. So again, if somebody has questions, please write to the chat. And Celine is ready to respond. I'm sure.
I was wondering, could I also quickly ask something directly here? Csaba?
Yes, I think why not? Why not?
Thank you, Celine, for your presentation. Very nice. I liked it. I enjoyed it a lot.
Thanks.
The topic is also quite nice, and I was wondering how much can these graphs grow as well? Because in the example that you showed, indeed, made the most sense to simply see the diff there in the graph. Visually, it was very clear. But if the graphs would grow as well, then that could also be a problem, right? It wouldn't scale as well. So do you have any plans there?
I actually have multiple plans. So Raincode created those major versions. There's 5 of them. So first I splitted the log according to those versions. So I would have like more different graph to have something that is clearer. But also here you saw a really indeed small graph, but I analyzed bigger and fuller graphs. And I saw that there is many nodes that are quite linear. You saw the first graph is only linear, just following. I think that if there is no difference in that linearity, maybe we could just collapse all those nodes and allow in our tool to just expand if you want to look. And I believe since change are quite localized, actually, yeah, like there are many linear nodes and then a bit of change and many linear nodes, we could probably arrive to something that would be readable. That's the goal.
Yeah, sounds reasonable. And I guess it's also probably, there are not so many patterns, right? Because you're also probably looking for these patterns of changes in between versions. And I'm guessing, so that if I can maybe ask another quick question before someone else gets the mic.
Yes, I think go ahead.
So I was wondering, did you have a survey with the guys from Raincode to see sort of to construct a database of knowledge from them, so to get these snippets and then possibly extract them automatically from the logs and try to map them directly on the graphs, or is that like too much out there?
We did have many chats with people at Raincode that are actually very interested in just seeing what we can do. As for extracting things that's not on the program right now, I wanted to like have a diff graph to show them and then ask, okay, where do you want me to go from here? So that was the plan. But maybe we could extract regularities, because when I analyzed the files, only 2 right now because I did it manually because the tool is not finished. But I saw that so there are 5 major versions, 4 of which are almost always the same. So we could, because those versions are like pre-processing and then cleaning up, and apparently that you always pre-process and clean up in the same way, so the graph ends up being the same. So we could probably extract things like, okay, so you really don't need to look at that because probably it's fine. So yeah, that may be interesting.
Oh, very cool. Sounds like really interesting. Looking forward to seeing the mature stage.
It's super cool. That's why I picked it first.
Yes, I think it's a very, very nice topic. One thing I wanted to ask, so it's also a clarifying question in a way. So as I understand, you have the logs from the, let's say, the migration, and you also have the syntax tree, right? And you have a diff based on that. Am I right with that? So you have the source code part and the execution logs.
Yeah.
And from the source code part, you do a diff on the syntax tree or something similar.
We plan to do a diff on control flow graphs to be able to mostly get a coarser diff, because right now when you use normal diff, you have lines and hundreds of lines of code, because this is like corporate code. So you can expect to have at least 2,000 lines of code in each file. So when you do a diff, even if there are not many difference, you end up with a diff that's 200 lines of code long and really hard to understand. So the idea is to use graph to more single out where things change. So it would be easier for the client if maybe they needed to retest something, maybe seeing the graph of the process of their file and seeing, oh, there is the difference. Maybe that would help them to target what kind of test they need to run and something like that. So that's the plan. I mean, we haven't started on that at all right now.
One remark that maybe you are familiar with the tool GAN3D. They do the diff on the syntax tree, and they have very nice UI for that. And I think Hagen is here, and it's from his team, from Martin Pinsger. So maybe you can have some nice discussion about this later on.
Can you repeat which one was that, Csaba? Csaba, can you repeat what you just said?
GAN3 diff.
Gumtree, yeah, right. I know. Okay.
And they have very nice visualization for the diff of the syntax tree. And they have front-end for Java, C++, of course, for COBOL not. So,
yeah.
But maybe you can use that somewhere.
Actually, it's funny because we have another project with Raincoat where we are using Gumtree for the moment to see how we can compare codes. Okay.
Yeah, that can be interesting.
I'll definitely talk to people that have interesting things to teach me. That'd be great.
Okay. So I might have one more question. So you are basically focusing again on the source code and the migration logs. So how often does it happen that something is changing externally?
It's changing what?
Changing externally. So something that you cannot prepare for. Let's say like the database schema is changed and something that you cannot see. Is it something that you also have to deal with, or it's not your work?
Raincoat people never talked about such things. I actually don't know how that pack-based tool works exactly, because that's none of my business and it's not supported anymore. But I guess since it's like an integrated tool for everything, the database, if the database schema changes, then that will be reflected in the pack-based code. But that would be indeed like big changes. But maybe since those projects migrating the code base from pack-based to normal COBOL only take usually a few months. So hopefully clients will not be foolish enough to change their database during that process.
Okay, I see. Okay, so I think very nice talk.
Thank you.
Very nice topic. So thank you very much for presenting this. And I guess you are also available again after the session in the lobby area.
I will be.
For interesting discussions. Okay, so Our next talk is, let me check the program, so from Jacob, and toward automatic decomposition of monolithic software into microservices. So we are jumping to the era of microservices. And as I see the camera, Jacob is ready for that. So
yes.
The stage is yours.
Can you hear me?
Yes, I could.
Is it loud enough and everything?
I think here it's yes.
Cool.
Yes,
then, then let's go. Do you see my presentation?
Yes, perfect.
Okay, then I'll start. Hello everyone, my name is Jakob Löhnitz, and today I'll present to you my paper Steinmetz toward automatic decomposition of monolithic software into microservices. So the general idea here is to decompose or refactor an existing monolithic system into a microservices-based architecture. I'm following here the idea of identifying latent boundaries within an existing monolith. I'm roughly following the book Domain-Driven Design by Eric Evans, and more specifically his idea of the bounded context, which essentially encapsulates that tasks, in air quotes, having interfaces towards each other. The problem is, although he defines it quite nicely in his book and explains it, identifying these bounded contexts manually is a very tedious task. So that's why my methodology that I developed in this paper automatically detects these existent, albeit hidden boundaries, then assist the software engineer in the decomposition process. Note, however, that neither similar methodologies in this domain of research nor my own do like a full automatic refactoring to microservices, but instead generate microservice candidate recommendations that can then assist a human and skip the identification step. So let's jump right into the first research question, which is essentially about how such a methodology could look like. Here I'm making heavy use of the notion of coupling, which I guess all of you know what that is. And more specifically, I looked into literature, what literature defines as the pillars of microservice for the following reason. I wanted to define a rationale, so to say, that ties input to the output. This was missing a bit from existing research, and that I essentially can say I have this input, I do something with it, and at the end I have this output, and I can reason about that this actually measures or tries to encapsulate what good microservice design even looks like. And these are the two most important ones. The first one service should handle only one task, so bounded context for that matter, which is nicely measurable with static coupling as well as semantic coupling. So semantic coupling to measure how semantically similar two pieces of code are, so that we can then reason about the higher this is, the more likely it is that they do similar or even same task. And secondly, that they should have independent software development life cycles, which is also what you ideally want, so you can have independent release cycles as long as interfaces don't change, which is nicely measurable by evolutionary coupling, which means to measure how much two life cycles of two classes, for example, overlap in the existing system. So this is the approach I came up with then. You supply just the source code and a VCS log, so a version control system, a Git log, Mercurial. I support a variety of systems, and that's uploaded. Then the coupling information is extracted out of this into 3 weighted graphs out of each input dimension. When I say input dimension, what I mean is these 3 types of coupling: static, semantic, and evolutionary from the previous slide. So we have 3 weighted graphs after this step, where the vertices or nodes in the graphs are classes. So I'm focused on object-oriented software. The edge in between is that there is some coupling, and finally the edge weight signifies a floating point from 0 to 1, so a percentage, how high this coupling is seen on the entirety of the system. And then in the third step, we merge all of this together using an edge weighting formula. So either you can let my methodology determine the most ideal weighting, or you can yourself say, okay, for me, having independent life cycle is more important, so I give this a higher weight of whatever you want. So the result of the third step is that we have one merged weighted graph that's persisted. The reason for this is I persisted into a database, since these first 3 steps, depending on input size, can take quite some time. And then finally, we cluster it using graph clustering, so essentially pulling apart the vertices into clusters. But how exactly that works, we'll see in a moment. Okay, I not only thought about this theoretically, but I also completely implemented this from scratch as a proof of concept. In classic 3-tier architecture, what you can see here, everything above the hairline is this first step of the analysis and persisting, and below that is retrieving it out of the database again, and then clustering. The reason, as I said, is that the below step you want to do multiple times usually, and it's also way quicker. That's why it's 2 separate ones. Here, quick impression. I know it's a bit small from the front end. So you have the control elements at the top, a graphical representation of the clustering that you can freely zoom in and out of as a graph. You can see which classes interface each other, how big they are. You can see how high the coupling between two classes is by the thickness of the edges. And you also have a textual view here on the bottom right-hand corner. And then finally, on the left-hand side, the metrics overview. So let's jump to the second research question, which is which numeric metrics are the most suitable for evaluating the output of this? So the microservice recommendations, the clusterings. For this, I looked at pre-existing and validated metrics that essentially try to measure what I want. So these are the two I selected, which is namely the cluster factor, abbreviated CF, and the modularity, weirdly enough, abbreviated Q. Those are the metrics work pretty differently, but they both try to measure the same thing in their core, which is to measure how connected nodes are within their own cluster compared to their inter-cluster, so in-between cluster connections. And some of you might already realize that this is the old thing of having high cohesion, low coupling, which is exactly what I want. So if clusters, so microservice recommendations, have high cohesion and the least feasible coupling to other ones, that's exactly what I want to measure, which is when the scores of the metrics go higher. So that's perfect. This is the entire set of the ones I devised. The first set here is only auxiliary. That's why it's its own. The second one is also its own because there you cannot strictly say higher or lower values is better. You probably want something in the middle. But it's still interesting to look at and how they correlate with other ones. And then finally, the last two sets you can see for each input dimension, there's one type. Here I'm using mean cluster factor, which is a slight variation on the cluster factor. And an average, which would mean if, average of the others. And finally, a total for both, which is just if after the edge weighting. So if you give everything a weight of 1, average and total would be the same, but they can also differ, of course. So let's look at some results. Here you see two heat maps for the mean cluster factor, MCF, on the top and the Q metric on the bottom. And on the y-axis, you see all the graph clustering algorithms. These are all state-of-the-art ones that were used. And on the x-axis, you see all the input projects, which are all large-scale, open-source, monolithic Java software application. And what you can already see is that the MCF metric on the top awards pretty high scores in general, and also the range of scores is fairly low. It's everything's in the upper third pretty much. And on the bottom, you can see that the Q metric, on the other hand, gives also lower values and also has a higher range. So to me, it looked a bit like the Q metric is preferred, but what I then did is to look at how they correlate. So here you see how they correlate. They have a pretty reasonable correlation of roughly 0.5 Pearson R, but the most interesting part about this figure is the bottom right-hand corner, where you can see a cluster of data points where the MCF metric has very high scores, while the coupling modularity Q has very low scores. So I specifically looked into these, which one is wrong, essentially. And if you do this in the graphical view, for example, this is the most extreme example. And here you can see that, well, this is not a very good clustering because we have one God service, so to say, that's huge, as you can see, and a few others that are connected to it. And thus, I concluded that the Q metric in this case is preferred over the MCF metric, since it correctly identifies this with a low score, while MCF gives a pretty high score. But there's other reasons that I found why Q is preferred, which I won't cover due to time constraints, but they're in the paper. So let's go to the last research question, which is which of these 7 graph clustering algorithms that you saw are the most suitable for this kind of methodology? Because there's dozens of them out there. So I did an extensive survey to find the ones that are feasible for my approach. A few of the criteria where they had to be deterministic. They have to do hard clustering, which means that one vertex can only strictly be in a single cluster. There's also fuzzy ones comparatively. And they have to use the edge weights as their means of doing the clusterings. There's also other algorithms that use some other means. So you see the same 7 again here on the x-axis. Here's 2 violin plots again with the 2 metrics. What we can directly see is that Chinese whispers generally performs the worst across the board, always pretty much. We can see that InfoMap and WalkTrap have a very wide range of values, specifically in the preferred Q metric. So these two together with label propagation are also not very good. MCL is pretty decent, but finally we can conclude that Closet-Newman-Moore and Louvain algorithm are the preferred ones, at least from this one. What I then again did is look at this is the same correlation you saw earlier, but now separated by clustering algorithms with the colors. So what you can see here in the top left-hand corner, the correlation R values, you see that orange and green, which are the two preferred metrics from the previous slide, have very high correlation. So it seems like both metrics agree that they produce good clusterings, which is why we concluded that Louvain and Clausen-Newman-Moore are the preferred ones for this type of methodology. What you can also see, of course, is that Chinese Whispers, for example, has also a very high or pretty high correlation, but there both metrics essentially agree that it is not producing good values. So it confirms that this works. So this concludes my presentation. Finally, the novelties that my paper brought to this domain of research, which is that I'm using 3 distinct input dimensions that are also fully implemented and working, and that I tied it into this rationale, and also that I only need source code and a VCS log as inputs. Previous or similar methodologies need some very precise models in a specific language, for example. I used and surveyed 7 state-of-the-art graph clustering algorithms that do not need the amount of services you want. All existing research has the big problem that you need to say, I want 10 services, which I find quite unusable because it's hard to know that a priori. And furthermore, existing research only used up to 2 at the same time. And finally, I devised an extensive set of numeric metrics to assess the quality of the output, which, as I said, was also lacking from existing research. That's it. Thank you very much for your attention.
Okay, thank you very much for the very interesting talk. I think I missed that we can do like clapping or something, but
that we can do what?
Everybody clapping for you, so everybody is doing that, I guess. So I think you, in the meantime, you received like 3 questions.
Okay.
And one is asking from Quinton whether is this language independent? So what do you do with traditional non-object-oriented languages?
Okay, so this is not entirely language agnostic, so it does need object-oriented language. Although the core of the methodology as well as the implementation I specifically designed and built to be completely language agnostic in the set of object-oriented languages. For my POC, I implemented it to work with Java software, but it's quite easy you have to implement a few abstract classes, and then it could also work with any other object-oriented software. So it's easily extensible, and I took care that that's the case.
Okay, I think it's understandable. Quentin, do you want to add something as a feedback?
No, this is very clear. Cool, thank you.
It could actually theoretically also work for non-object-oriented software, as long as you have as long as you can define some type of unit, so to say, which in this case I used a class. But theoretically, if you have a module or something in a functional language, that could also work, but I didn't focus on that.
So this may not be too relevant, but some modern languages are kind of a mix between OO concepts and then design concepts that are not from object-oriented programming.
Yeah.
Is this something you have considered? This is a very, of course, edge case.
I mean, looking at the 2 big ones, probably Scala and Kotlin, they're both OO compiled to the JVM, so that's working perfectly fine. Yeah.
Cool.
But if you were thinking about other ones, no, I didn't specifically thought about that. As long as they have some object orientation, or as long as they have the notion of a unit or a class, what I specifically used, it'll work with the methodology.
Yes, I guess the main point in your algorithm is that you have to find that unit that you basically base your graph on, and then that you interconnect.
Exactly, that's what the node is in the end. Indeed, that's why it's important.
And I guess your implementation is like that. First you just process the Java files, and then you run your algorithms on the top of that. So I guess your implementation in that way is language independent.
Yeah.
Except for the final.
It's just exactly the building. I have one like shared model, data model, and that is agnostic, and extracting the information, for example, in the POC out of Java software, that of course is language dependent, but then the shared data model has no notion of Java whatsoever anymore, and it works with anything. At least that's all.
Okay, so since we have more questions, I just jump to the next one.
Sure.
We don't have so much time left, so I guess we have 2 in queue, and Tom has received more upvotes. So the question is, did you consider other metrics than MCF and Q?
Yes, I considered others, more specifically out of the, so there's also a research domain that looks at a similar subject with a topic that is doing this just in a single system. So determining, for example, how module structure could look like for any given software, regardless of architecture, which is actually where the cluster factor metric comes from. But the others out of the domain were not as feasible, but I looked into it, yeah. But I cannot give you any concrete reasons why I discarded the other ones. I would have to think about it because it's in my thesis.
Okay. Tom, do you have something to add? The question.
No, I should read the thesis, I guess, to find out the details of his answer.
I mean, another one that works on paper, seems to work nice, is to just measure how much of the coupling of the edge weights are intercluster. But then I actually that's the other reason why one was preferred over the other metric. It turns out that, of course, if you make your services super large and only a few, you can trick this metric, so to say, to achieve very low scores, which is good in this case. So this is another one, a main one that I actually considered, and not only considered but also used. But you, as I said, you can easily trick it in achieving fake high results, which the other two don't allow as easily.
Okay, so I just jumped to the next question, which is from Eleni. The question is, how can tangled designs affect the recovery of information hidden in these graphs?
How can what designs?
So how can tangled designs affect the recovery of information hidden in these graphs?
Maybe you can elaborate if you,
Yeah,
maybe.
Okay, here's the thing. So part of my PhD days, quite some time ago, I used to investigate the structure of systems. In my case, it was to recover small reusable parts. I mean, the process is the same. You want to somehow separate parts of the same system to do something. In my case, was to find good reusable parts of that system. So a very, very, very common problem was tangled designs. And by these, I mean many circular cyclic dependencies in your code that whatever graph you build, if you try to cluster, good luck. Everything becomes too messed up to give you any meaningful information afterwards. So here, this can be really important. And there is actually quite some work that inspired me, some work that is mine on how to try and, recover the parts that are basically either widely used in the system, because this can also affect a lot the way your clusters would look like.
Yes.
And also how to find good ways to draw borders where you should actually separate without affecting the overlapping functionality that should be unique to that part of the system. And if it's functionality that's throughout the system, to try to separate that into a single cluster. So, I mean, it's a different end goal, but you might face similar issues. So I would be more than happy to provide more related work on this and some papers that have faced these issues.
Yeah, sounds good. So the main thing where I faced this as well, which is actually future work of my paper and thesis, is that I specifically see this for traditional like web-based software, that stuff like data classes, for example, they are on purpose shared, of course. So it's hard, or utility classes, also a good example. So they are they are sometimes attributed to or let's say that it makes indeed the clustering very difficult, because they essentially had to be attributed to a lot of stuff. Of course, in most languages, that's not strictly a problem if you really do the refactoring, because you can have it in your class path or something and then just compile it into 2 services. I mean, that's fine. But the need for the clustering, that's the problem. I also generally saw that this was just judged by myself, there's no metric or something. Looking into the input projects, the open source applications that achieved high scores, I gotta say that they also generally had a better architecture. Like that just made it a bit easier to cluster. But nevertheless, also some that were very convoluted and stuff, it still found, subjectively at least, a good clustering. But yeah, this is an interesting point. Yeah.
Untangling these architectures can give you better architectural views. Actually, I did a paper on that, on how to find good spots that mess up your graph structure. And if you were to remove those links just to do architecture recovery, you can actually get better results. More clear clusters at least, right? So there's a lot of inspiration you can draw from this work, and please feel free to ping me. I would be more than happy to discuss and provide the links to that.
I will happily contact you because sure. Sounds interesting to me.
Yeah. Okay.
Thanks.
Okay, thank you for the questions. So actually, we have one more question from Tom, and I also have a question, but we are, I think, at the end of the time of this session's time slot. So I'm just asking Eleni and Anna whether we go on here or we go to the lobby area, to the tables.
Let's move it to the tables, also grab some coffee, but yeah.
Okay.
Okay, so see you at Discord. Let's continue this nice discussion and see you back here in 15?
Yes.
Yeah, in 15 minutes then for the next session.
So,
okay. Thank you.
Thanks.
Okay.
Yes, thank you. And I just want to thank also Quintan, who was in the background and helping me. So thanks for you all and also the presentation.
You're very welcome.
See you.
I thank you both, Csaba and Quintan.
And then I also thank Eleni.
Let's stop this cycle. It will never end.
Talking about the cyclic dependencies.
Yeah.
Then we can, okay, so we'll go to the Discord and continue with the session's questions there. Cool. Yeah.
Okay.
Thank you. Thanks for your attention.
Yeah.
So we are preparing to start our next session. We have okay. Welcome everyone. I should say welcome back. I'm Anna Oprescu. I'm a lecturer in the University of Amsterdam, and I'm very happy to be the chair of the second session of SATToSE today, mining software repositories. Our session today will have 2 presentation abstracts and 1 artifact demonstration. So with that, I would like to give the floor to the first presentation abstract by Zainab Abu Khalil. I hope I have pronounced everything correctly.
Yeah.
Zainab, the floor is yours.
Can you see my screen first?
Yes.
Yeah. Okay. So hello, I'm Zainab Abu Khalil. I'm a PhD student at University of Lille and University of Mons. I'm supervised by Professor Tom Menz and Rose Duchien. I'm here to present my work on the impact of release policies on bug handling activity, a case study of Eclipse. This is an extension of already published work. Here we go. No, it's not good. Yeah, okay. Due to today's competitive business world, software organization must deliver new features and bug fixes fast to gain and sustain the satisfaction of users. The concept of rapid release cycle was introduced by agile methodologies, which claim that shorter release cycle offers various benefit to both companies and end users. The adoption of rapid release cycle has led many software projects to change their development processes toward the rapid release models. It's important to study how the software is evolving and the impact of such changes on the software development lifecycle. Our focus will be on the software maintenance part. In our study, we did a quantitative analysis on the bug handling rate and time over years and before and after each release. Also, we consulted maintainers to get their feedback about the adoption of rapid release in the software. We selected Eclipse Core as our case study because it's a large and mature project that has a sufficiently long release history with bug reporting activity. Also, and more importantly, since Eclipse has, since September 2018, Eclipse switches to a 13-week cycle instead of annual release cycle. So we analyzed 16 consecutive releases. As we can see here in the figure, the first one shows the Eclipse Core project release schedule, which is composed of several successive milestones of 6-7 week interval. Then after that, a feature freeze is imposed, during which maintainers are no longer allowed to introduce code changes, new features, and have only to concentrate on bug fixing and testing for the release under development. During this feature freeze period, a number of release candidates is released. But this, since the switch, we have now, instead of 7 milestones, we have only 3 milestones, and after that, 3 milestones of 3-week interval, and 2 release candidates of 1-week interval only. So it was shortened to 16-week total. We intuitively expect Eclipse Core project contributors to handle bug more intensively in the period before than after release date, so pre-release bugs, as they strive to resolve and fix as many bugs as possible in the upcoming release. Therefore, we empirically analyze how the bug handling rate is evolving across releases, and also we investigate if developers differentiate between bugs according to their severity. To do so, we defined this matrix, which is the resolving rate, which is the number of resolved bugs over the number of reported bugs, the fixed rate, which is the number of fixed bugs over number of resolved bugs, another matrix, which is resolving rate before, which corresponds to the number of bugs reported before, so pre-release bugs, and the resolution rate after, which is the number of resolved and reported bugs after the release is already published. Here in our figure, we see the y-axis corresponds to the rate and the x-axis shows the release. We can see that the resolution rate tends to decrease over releases, but there's no significant difference between before and after each release. But the fixing rate is higher before than after a release. So they tend to fix more valid bugs before than after a release. And also we found that there's a tendency to resolve more normal than high severity bugs after the release. So they tend to fix normal bugs, more and more normal bugs after the release is published. Even after switching to rapid release, it's the same results. So still there's no difference between before and after, the same. And Eclipse maintainer confirm our results regarding that they don't differentiate between bugs based on their severity. Here, since developers strive to deliver project release with as few bugs as possible, we assume that intense bug handling activity before an upcoming release lead to faster bug triaging and fixing time than after the release. We thus investigate the difference between these two periods in terms of day elapsed to triage and fix a bug. We used survival analysis technique to model the time expected to triage a bug. The time to triage a bug is the time from bug is reported till the time bug is assigned. The time to fix is the time since it's reported to bug is fixed. So we use survival analysis technique to model the time expected to triage and fix the bugs. Here I'm showing a triaging example triaging time. As we can see, this is for release 4.2 and this is for release 4.7. It shows that more bugs, like after as an example 100 days, more bugs reported before the release are. There's a high probability for bugs reported before the release to be triaged than after the release is published. But as you can see for 4.7, there's no difference between before and after. So this difference is decreasing over releases till there's no difference for the quarterly releases, the new rapid ones. So regarding the triaging time, I will summarize our finding for the time bug handling time. For annual releases, bugs tend to triage faster before than after the release. Also, the transition to rapid releases has been beneficial. Have been beneficial since such difference in triaging time is no longer observed. Moreover, bugs are triaged faster after the switch to quarterly releases. We find that it's now triaged faster. Also, we studied the bugs regarding the bug severity. We find that it doesn't seem to have a measurable effect on the bug triaging time before and after a release. So it doesn't matter if it's high or normal or low severity bug. Regarding the fixing time, we find no difference between the bug fixing time before and after the release. Bugs are fixed faster after the transition to the quarterly releases. Just to differentiate before and after the release, it means pre and post-release bugs. And bugs are fixed faster after the transition to quarterly releases. And also, bug severity does not seem to have a measurable effect. So it seems in all our results that they don't really consider the severity of the bug. And the consulted Eclipse maintainers confirmed our results regarding this analysis. Here, in this essay question, we focused on bug handling rate again, which is the resolving and fixing rate, but during the feature freeze period of each considered release and the effort spent in these periods. We hypothesized that bug handling process is more intense in the feature freeze period than in the development period. As I already mentioned, the feature freeze period is a period where no feature is added. It's only for testing and bug fixing. I will summarize our results here. I will not show graphs. So what we find is that there's no observable difference in fixing rate between the development period and feature freeze period of each release. However, the feature freeze period focuses more on the bugs being reported in the same period than on bugs reported earlier. So it seems that they focus on the bugs that are result of a testing in that period, not the one reported before the feature freeze period. Moreover, more effort is spent on fixing bugs during the feature freeze period than during the development period, which is normal, which is expected. This difference in offer appeared to have increased for quicker releases. So the effort spent in feature freeze now is increased after the transition to rapid releases. Now our fourth research question. Here we focus again on the time, handling time before and during the feature, but not before and after release, just during the development and during the feature freeze. We hypothesized that bugs are triaged and fixed faster during such feature freeze period due to the increased pressure to resolve as many bugs as possible for the next release. We also assume that the triaging and fixing time of bugs targeting the current release will increase, since developer may prefer to focus on bugs of the next release rather than the ones targeting the current release that has already been delivered. To this end, we compare the difference in bug triaging and fixing time between the current and the next release with respect to the feature freeze period. So in our analysis, we distinguish between 4 categories of bugs. So C1 here, it corresponds to the all bugs of the current release reported in the development period of the next release, which is the 4.6 as an example. C2 is the bugs of the current release reported in the feature freeze of the next release. N1 are the bugs of the next release to be delivered, reported in the development period, and N2 is the bugs of the feature freeze of the next release reported in the feature freeze of its feature freeze. I will go fast here. I will just go to the results because I already took a time. So what we observe is that it takes less time to triage and fix bugs during the feature freeze period of the next release compared to the current one. So bugs of the next release are triaged and fixed faster in the feature freeze than the one already exists from the current one. We find bugs of the current release that are triaged and fixed during the feature freeze period have stayed open longer compared to those in the development period. So what we find that during the feature freeze period, the bugs of the current release have been opened for a longer time than the ones that they are already reported in the development period of the next one. The third observation was that the feature freeze period does not affect the triaging and the fixing time of the bug for the next release. So the bugs of the next release are fixed and are triaged and fixed as soon as possible whenever they exist. It's not important if they are reported in this period or the other period. To summarize our work, our findings regarding evolution of the bug handling process of Eclipse, we find that before changing their bug handling process, project communities should carefully assess the pros and cons of such changes upfront, plan ahead these changes to avoid negative impacts, and measure after changing the process if the target improvement have been reached. Also, more importantly, researchers need to be aware of such changes in the bug handling process when carrying out empirical studies, since the effect of these changes may play an important role in the obtained result, as we have clearly observed with our Eclipse case study. Regarding bug handling during the feature freeze period only, feature freeze period impose extra stress during rapid releases, since they tend to be relatively short, and in addition, they take away an important part of the time that could otherwise be devoted to development of new features. Also, feature freeze period need to be preserved, since they allow to spend more focused effort fixing for the upcoming release. In addition to this, they should invest in test automation, exceptionally in the presence of rapid releases. All our finding, we find them with our quantitative analysis and also with the feedback we get from Eclipse. Regarding benefits and challenges in switching to more rapid release policy, our finding for Mozilla and Eclipse highlight that the findings for Mozilla and Eclipse highlight that careful preparation and planning is key for successful transition to faster release cycle. It enables the developer community to become more effective in bug handling activities, provided the presence of good testing plan, good release management policy, and also adequate automated tooling and support processes. Also, other projects can benefit from lessons learned from these two systems. Thank you. That's all.
Thank you very much, Zainab. Thank you. I'll grab the reactions here. Questions. I've seen that there are already some in our Discord channel. So I'd like to start with the one from Felipe. If you have any plans to analyze other projects as well.
I'm already analyzing Mozilla Firefox, but it's not like really adapting rapid releases. They killed a stabilization channel, Aurora stabilization channel. So they killed it just to fasten, just to make the release cycle more rapid. They decreased the release cycle by 6 to 8 weeks. So yes, I'm considering Eclipse, but it's not like they already switched in 2012 to a rapid release one, but recently in 2018 they killed Aurora, so their release cycle is now more faster. So I'm studying this switch, not the older one.
Right. Okay. I have also a nice question from Eleni, which goes something like this. What questions would you ask the developers about their processes to be able to give them advice, like appropriate advice, when they consider adopting a different release cycle? Well, especially a faster release cycle, because I'm guessing some of them, they might even consider adopting a slower one. But when they would consider changing the length of their release cycle. So do you have some idea of if you'd go to the developers to ask for their advice first on setting up these questions that would allow them afterwards to reflect on should they go faster, or slower with our release cycles?
Yeah, it depends. As an example, if we talk about like maintaining software maintenance, so my focus will be about testing. If they automating their testing, they have is there like sometimes because if their software is not stable enough, maybe they can't like, because my results as an example highlight for a mature and stable projects. Maybe that's why they have a successful transition to rapid releases. So it depends on the software, if it's stable, if they have a good testing, or maybe because whenever you need to adapt to rapid releases, you have to do automated testing. Also, you have to add more tools, maybe also include more contributors or more maintainers. Depends on your software. So this might affect if I want to advise them to adapt it or to adapt rapid releases on depending on their situation.
Yeah, so to just very quickly chirp on this, because Tom is also asking about like when we could think of a slower cycle. So you could think of when you're maybe prototyping and you might go just too fast in your sprints, and then you really need to maybe relax that sprint a little bit because you're going too fast, and the team doesn't spend enough time reflecting on the design that they have, on the approach they have to discussions. So those could be cases, for instance, of going back to the origins, let's say, and doing it in a different way, and automation as well. So indeed, these are points where you could ask the developer to reflect. It's really nice that you're doing this kind of work. I like it a lot as well. Csaba has another question: if whether you look maybe at different release strategy affecting the reopening of a bug in the bug report system.
Yes, I did. But the thing is that we didn't have enough number of reopened bugs. That's why we can't rely on such study. I tried to do such analysis, but the thing for Eclipse, we didn't find enough reopened bugs so that like we can compare really before and after transition if the reopening is increasing or decreasing, what is changing. So it was a lack of enough number of reopened bugs.
Good. And then I also had a quick one, which was a little bit based on the reflection part. But first, let me give the floor to Alexander Decan. He is discussing with Tom about some Python project where this might have been happening, the slower mode. Alexander, do you want to open your mic and directly participate in the Zoom session? If not, we can keep this for the table, coffee table in the break. Yeah, no problem. We do it in the coffee break. So to go quickly to mine, to my question, did you, as a developers, to reflect on these findings that you have? Like, I really liked your graphs, and your findings were really clear. And I was wondering if you also went back to the maintainers and asked them to see how they reflected on your findings. So to see whether they truly felt a pressure by going to a different release cycle, and they also felt more satisfaction because it seems to be more beneficial to have a smaller release cycle, right? A faster release cycle, sorry. Do you have any idea about that? Was there anything that came through in your discussions with them?
So you mean like, did I show them my results and ask them about them?
Mm-hmm.
I did the survey before completing all my results, so I asked them before. Then I confirmed my results by their feedback. So I didn't really like show them my results, and then after that ask them about what they think about my results. The thing is that I did the survey before.
And did it fit? So it did show that there was a good match between your findings and what?
Yes, they most of them, my results, they confirmed my findings. Yes, but yeah, I didn't show them my findings. Then I asked before, but then after that, I find that it confirmed what they said.
And another quick question from Felipe is if you did any filtering on the bugs.
Yeah, sure. We did a lot of pre-processing on the bugs. We filtered. Okay, I can't say like it's 100% these bugs are bugs. I filtered. I removed the enhancement. I tried to remove all the enhancement. I removed the bugs like with the unspecified version because I did like on release basis my study. Also, I did pre-processing on because I studied the triaging time. There was a lot of bugs with no assignment field. They were assigned to groups. Then after that, we did some pre-processing to find to whom they were assigned, if they are assigned or not. Yes, I did a lot of filtering on the bugs. So yes.
Nice. Okay, very good. Thank you very much, Zainab, again. Good presentation, good discussion afterwards. Yes, indeed, Tom is right. Lots of nice questions and answers. We should continue that in the coffee break in your voice channel. And meanwhile, we can go to our next presentation. And I will enlist the help of my volunteer. Yes, thank you very much.
Hello, I'm Mehdi Golzadeh. I'm PhD student in Software Engineering Lab at University of Mons. In this study, we have proposed a new approach for detecting bots in GitHub pull request activities based on command similarity. This research is presented to the 13th seminar series on advanced techniques and tools for software evolution. To begin, we need to get familiar with the concept of online coding platform. Today, software developers, especially open source developers, are increasingly using these platforms to commit their changes to codebase, use new methods of code contribution like pull requests, and also doing code reviews. As these platforms are getting more and more popular and they host millions of projects, maintainers tend to rely on bots to carry out routine tasks and to interact with project members to facilitate their works. Studies have shown that bots improve collaborative development in several different ways. For example, improving software quality by automated refactoring, generating patches for bugs, continuous integration, automatically closing abundant issues and pull requests. What's a pull request? It's a method of code contribution which allows developers to participate in different projects without having direct commit access. To submit a pull request, one can create a fork or clone a repository, make changes, and submit a pull request easily by putting a title, a description, and clicking on the Create Pull Request button. After submitting a pull request, it will appear in the list of pull requests, and maintainers will decide whether to merge it or not according to the quality of changes. If you have a look at the list of pull requests, we can see that there are a lot of comments and discussions in these pull requests. And if we open one of these, we can see that bots are involved in these discussions. We believe this can bias a study's targeted pull-based development and more generally social codings. For example, the presence of bots makes it difficult for empirical studies to distinguish human behavior from automated behavior, and other studies like identity merging or social aspects like contributor onboarding, contributor abandonment, team productivity, and team collaborations can be influenced by the presence of bots. More specifically, in our last study about acceptance or rejection of pull requests, we noticed that proportion of accepted pull requests with presence of bots is almost twice pull requests without bot comments. This means they need to be considered by researchers. This subject is directly related to our goal in SATToSE project to study software ecosystem health. So we decided to find a solution for this problem. The current method to identify bots on GitHub is based on combination of different methods. It's a manual and effort-prone process and not easily reproducible, like looking for previous studies about well-known bots and the presence of a string bot in user identity. So having a ground truth was an important task in our study. We created a dataset of accounts that are currently active in 1,200 projects of cargo ecosystem. We manually identified 42 bots and 250 human accounts, and all of these accounts manually and independently checked and verified by two distinct authors of this paper. The underlying idea of our study, which is to propose an automated approach for detecting bots in GitHub, is based on the hypothesis that bots exhibit more repetitive messages than humans, since they are expected to automate repetitive tasks, while the variation in comments made by humans is expected to be higher. This figure shows comments of a sample bot in our dataset, and as it's clear, comments are very similar.
Wouter, can we
So we decided to measure this similarity.
Okay, sorry, as you might have realized, there are some issues with the quality. So I will try playing the video from my laptop to see if it improves. If you continue seeing that something is wrong, please somehow indicate this to me that it didn't fix the issue. Otherwise, yeah, it's our last effort. Sorry, Mehdi. Let's see if it works now, okay?
Thank you, Eleni.
Sorry, because I understand that it wasn't very readable.
Okay.
Is it okay now? It's okay?
Yeah.
So I will continue broadcasting the video. Maybe it's a good idea to play it for the beginning. Maybe we will be a few minutes behind. Yeah. Okay, so we'll start the video from the beginning, and here we go. So.
Hello, I'm Mehdi Golzadeh. I'm PhD student in Software Engineering Lab at University of Mons. In this study, we have proposed a new approach for detecting bots in GitHub pull request activities based on comment similarity. This research is presented to the 13th seminar series on advanced techniques and tools for software evolution. To begin, we need to get familiar with the concept of online coding platform. Today, software developers, especially open source developers, are increasingly using these platforms to commit their changes to codebase, use new methods of code contribution like pull request, and also doing code reviews. As these platforms are getting more and more popular and they host millions of projects, maintainers tend to rely on bots to carry out routine tasks and to interact with project members to facilitate their works. Studies have shown that bots improve collaborative development in several different ways. For example, improving software quality by automated refactoring, generating patches for bugs, continuous integration, automatically closing abandoned issues and pull requests. What's a pull request? It's a method of code contribution which allows developers to participate in different projects without having direct commit access. To submit a pull request, one can create a fork or clone a repository, make changes, and submit a pull request easily by putting a title, a description, and clicking on the Create Pull Request button. After submitting a pull request, it will appear in the list of pull requests, and maintainers will decide whether to merge it or not according to the quality of changes. If you have a look at the list of pull requests, we can see that there are a lot of comments and discussions in these pull requests. And if we open one of these, we can see that bots are involved in these discussions. We believe this can bias studies targeted pull-based development and more generally social codings. For example, the presence of bots makes it difficult for empirical studies to distinguish human behavior from automated behavior, and other studies like identity merging or social aspects like contributor onboarding, contributor abandonment, team productivity, and team collaborations can be influenced by the presence of bots. More specifically, in our last study about acceptance or rejection of pull requests, we noticed that proportion of accepted pull requests with presence of bots is almost twice pull requests without bot comments. This means they need to be considered by researchers. This subject is directly related to our goal in SATToSE project to study software ecosystem health. So we decided to find a solution for this problem. The current method to identify bots on GitHub is based on combination of different methods. It's a manual and effort-prone process and not easily reproducible, like looking for previous studies about well-known bots and the presence of a string bot in user identity. So having a ground truth was an important task in our study. We created a dataset of accounts that are currently active in 1,200 projects of cargo ecosystem. We manually identified 42 bots and 250 human accounts, and all of these accounts manually and independently checked and verified by two distinct authors of this paper. The underlying idea of our study, which is to propose an automated approach for detecting bots in GitHub, is based on the hypothesis that bots exhibit more repetitive messages than humans, since they are expected to automate repetitive tasks, while the variation in comments made by humans is expected to be higher. This figure shows comments of a sample bot in our dataset, and as it's clear, comments are very similar. So we decided to measure this similarity of comments by two well-known distance metrics. The first one, Levenshtein edit distance, which works more on the structure of the text by counting the number of single character edits like deletion, insertion, or character replacement. And the second one, Jacquard distance, which works more on the similarity of the content and compares the number of distinct common words in two strings with the total number of distinct words in them. We computed the Levenshtein and Jacquard distance of all pairs of PR messages of each identity. The figure shows mean Levenshtein and Jacquard distance of all comments of each identity. Clearly, humans have higher Jacquard and Levenshtein distance than bots. Also, we can see that both distances have very similar results, but the presence of dots outside the diagonal indicates that both distance metrics are not redundant. In this figure, we can find bots and human accounts with the same Jacquard distance but different Levenshtein distance, and conversely, we can find human and bot accounts with the same Levenshtein distance and different Jacquard distance. Even if humans can be identified on the basis of higher mean distance, this does not effectively distinguish them from bots, since we observed that some bots also have such high mean distances. We manually inspected those bots, and we noticed that while they do have repetitive messages, these messages follow several distinct patterns, implying a higher distance value when messages belong to different message patterns. We assume this similarity comparison works, but it's not enough to catch all bots. Therefore, we came up with the idea of counting the number of patterns. In this figure, we can see comments of a DevOps bot with 3 different message patterns. So we decided to compute the similarity of sets of comments instead of all comments, as we knew messages follow several distinct patterns. We guessed that human comments spread across many small clusters, and bots will have very small number of large clusters. Therefore, we applied an intermediate clustering to identify the number of patterns of comments for each identity. We used DBScan, one of the popular machine learning techniques for clustering tasks. We selected this technique because it has the advantage of not requiring to specify the number of expected clusters. It can generate clusters of unequal size, and also it allows clusters to contain a single item. We used combined Levenshtein and Jacquard distance as our distance metric. The figure shows the number of resulting clusters and the number of considered messages for each identity. As we can see clearly, bots have a lower number of clusters regardless of the number of messages, and all 42 bots have 10 clusters or less. We can also observe that 249 out of 250 humans have at least 14 clusters. Our approach can classify bots based on the threshold of 10 clusters with the recall of 100 and the accuracy of 97.7%. The limitation of our work mainly lies on the size of our dataset. We have a dataset of only 292 GitHub identities, all from Cargo ecosystem. Another limitation of our work is that the cluster of comments is the only decision factor, while, as we saw, the number of comments could be considered as another factor. We decided to continue this study, so we already manually verified 5,000 accounts from 169,000 repositories from 37 ecosystems. We want to create a classification model instead of a threshold for clusters, and also we want to include more features like number of comments, empty comments, and Gini value as distinguishing metrics. And also we want to provide a tool. To sum up, we explained about pull-based development and presence of bots in social coding platforms and how this presence can affect studies related to software ecosystem health. We explained our approach and the result. Our approach is based on the comment similarity and clusters of comments. We computed clusters of comments with the combination of Jacquard and Levenshtein distances. We showed that our approach classifies accounts with high precision and recall. We also further worked on this subject and we created a bigger data set, and we considered more features to make a better model to classify, and also we decided to create a tool to make it more useful for the community. Thanks for listening, and any question?
Thank you very much, Mehdi. And I'm really glad that the technical difficulties were fixed in time for us to enjoy your presentation. Thank you, Eleni, for that. So let's go to some questions. There's already one note from Eleni. I think she has a comment here that there's an MSR paper releasing a data set with both committing code and identification technique that authors propose. Could you use their data set and compare with their methodology?
Actually, yesterday I read about this paper and I listened to the presentation for Parsai paper, and I noticed that their data set is very big, but we cannot use their data set, as Tom said, as Tom explained, because we are working on pull request and issue comments, not commit comments. So our approach is completely, I don't know about their approach, I'm not sure about their approach, but our data set is completely different.
Okay, cool. That's then clear. I wanted to then go to Alexander's question. Are you aware of more efficient distances that could better capture text structure and content? And would it make a difference to use them?
There are a lot of type of distance metrics, but we tried these two distance metrics, and actually we found a good result. So we stick with these two metrics, and we try to combine them to consider both structural and content-wise to compute the distance and similarities.
If I may jump in this one, because I had my a similar question in mind. So, how did you because you say you combine the scores, the Jacquard and the Levenstein scores. How do you combine them exactly?
What do you mean? But we combine the distance between pairs of comments, as I explained in my presentation. We computed all pairs of comments, and we computed mean of between Jacquard and Levenstein distance.
Okay, so it's the average between the two distances.
Yeah, the average between two distances.
Right. Okay. And you haven't played around maybe with different weights, or this was already good enough, I guess.
Yes.
Right.
And actually, as I explained, we extended this paper, and we have a classification model with high precision and recall, and we are completing our approach with the classification.
Cool. And then there's a question about the motivation, let's say, from Hagen Turner, somewhere between motivation and actionability of the results you get. What is the benefit of detecting these bots? So I think you touched a little bit on that, because you mentioned that they could become disparaging to a repository by discouraging contributors if they have a really bad behavior towards them. But could you elaborate on that?
Actually, it's not just for research purposes. I don't know how to say. I have seen some presentation. Actually, the presentation will be tomorrow about BOTC papers. BOTC workshop will be tomorrow. But I have seen the presentations before, and there are a lot of. They mention a lot of problem with developers that causes by bots, and not only detecting them for research purposes is important, for development purposes is important, and to make developers comfortable where they working, or approach works for research purposes.
Okay. Now that's very cool, and I think that there might be some more questions for you during the break in the coffee around the coffee table.
Yeah, I will be there for answering questions. Thank you.
Very good, very good. Thank you.
Thank you very much.
And with that, let's go to exactly David Arroyo's presentation, Dame Gender Writing and Comparison Detection Tools.
Let's hope for the best. If there are any issues, please just point it out to me while playing the presentation. Okay, here we go.
This speech is about Dame Gender, writing and comparing gender detection tools. The authors are David Arroyo Penéndez, Jesús González Barahona, and Gregorio Robles. This work is part of a PhD. I am the thesis student, and the thesis director is Jesús González Barahona. The objectives are to compare APIs to detect gender from a name, to apply machine learning to classify nicknames, divinities, or name names as male or female, to understand the impact about open data in statistics about names and gender versus datasets created by companies or free software communities, to apply these tools to the scientific communities or communities based in internet. Dame Gender in few words. Dame Gender is a gender detection tool from the name, open dataset from official statistics, free software. Dame Gender can be applied for gender classification in datasets, software repositories, science, Wikipedia, mailing lists, or internet communities in general. Dame Gender.
I'm gonna pause the presentation. Is the sound okay? Because no. Okay, I'm really sorry. It seems that this is an exciting session, everybody. I'm really sorry for this. Okay, maybe can we try from another PC again? Wouter, can you try to play this recording again from your PC? Because we didn't finish this issue in our test, so maybe it will work now.
Yes, I can do that, but I think this is how the video was uploaded. If I play it on my laptop, it sounds the same, so
Yeah.
Sounds the same.
I think
Okay.
it's within the source. It's not part of the.
Eleni, we briefly spoke about this before, and this is just the quality of the video.
Okay, I cannot do much more. If I turn the sound a bit lower,
It's fine.
you can turn on, basically I want to reduce the noise on my side and you can turn up the volume on your side and hope for the best. Yeah?
Yes.
Okay, so I'm gonna go to the beginning of this slide. Okay, so I'm hitting resume. I'm sorry, everybody. I hope for your understanding. This is our first virtual event and let's go.
For internet virtual to be applied in internet communities, the social impact is about, due to the importance about sex variable in sociology, is an important problem in natural language processing. To reduce the gender is an objective in United Nations. You need data and calculus to reach it. You can download source and article to make a good tracing with git clone. Okay, introduction. Gender detection tools in the bibliography. The most used method to infer gender of participants looking for their name is our method. We can infer gender from faces in images. We are using this method with good results too, but not in this article. To infer gender from handwriting annotation or infer gender from speeches. Research. We evaluate the quality and accessibility, including price, of different existing solutions. We discuss their limitation and we investigate what happens with those names not included in official statistics, for example, nicknames or diminutives. Contributions. An evaluation of the quality of different solutions applying well-known metrics. A tool called DemGender, guessing gender from a name, giving support to Spanish and English from the open data census provided by the states, with to understand current technologies in detail. This tool has been compared with APIs using an international dataset with good results, and machine learning solutions for states not found in the census dataset to approach the problem with nicknames and diminutives. Technologies. Natural language for natural language processing, scikit for machine learning, NumPy for numerical computation, and Matplotlib to visualize results, Perceval to link with retrieve data from internet communities. Datasets. Ways to build a good dataset about names. A census published with a free license, a dataset released with a free license in a free software package, a dataset retrieved from commercial APIs, and a dataset which is the result of an investigation and that has been released publicly. In the DemGender, we are comparing a scientific dataset with the commercial solutions, and in the DemGender we are using statistics released with a free license by the states as dataset. Then the dataset about names from official statistics in DemGender. We have datasets from North America, United States of America and Canada. South America we have a dataset from Uruguay. And Europe we have a dataset from Ireland, United Kingdom, Spain, Portugal, Iceland and Finland. Oceania we have dataset from Australia and New Zealand. The result in this paper has been reached with Spain, Uruguay, United States of America and United Kingdom official statistics. Comparison of the different features that name gender inference services is about database size, regular data updates, unstructured string, handle surnames, non-Latin alphabets, geolocalization, exist locale, assignment type, free params, guessing with machine learning, free license, APIs, and free request limited. Okay. In general, the commercial solution, there are a lot of features reached. The gender has the guessing names with machine learning if the name is not in a database as innovation. This is the innovation. Okay, comparison of measures of the quality of the results for the tools under study. We have chosen the Lucia Santamaria and Elena Mihaljevic data set. Is built with a scientific method. Its name is classified as male or female, deciding we are investigating in personal web pages, articles, scientific web pages, self-reference, Wikipedia, many measures to decide. Then this table is about different accuracy measures. The best solutions is gender happy and genderized, but the gender is obtaining very good results using these methods, this machine learning algorithm, super vector machines. The confusion matrix is gender happy as best solution, and the gender and the rest solution is so good too. In general, okay, a confusion matrix is so important. The diagonal is I. Male with male, female with female. Good results. Comparison of measures of the quality of the results for the tools under study. The gender is obtaining very good results due to low errors. Okay, a comparison of our machine learning algorithms and accuracies. Super vector machine, random forest, NLTK, natural language toolkit with navy badges. It's very good options. There are 3 very good options. There are another options with good results too, but there are 3 algorithms with very good results. Okay, this machine learning is using Uruguay, Spain, United States of America, and United Kingdom for the training, and we are using Lucia Santamaria and Elena Mihaljevic as base of truth to compare these results. Conclusions. The market of gender detection tools is dominated by companies based on payment services through APIs. This market could be changed thanks to the free software solutions and open data due to give more explicative results for the user. Although the machine learning technique is not new in this field, it's an incentive for researchers in computer science to create free software tools, but it's new the application. Guessing if it's not in the database. This advanced in computer science could be giving support to study the gender gap in repositories and mailing lists. So the application of the engine in real cases is the next step in this research.
Thank you very much. Thank you, David. You are here with us, right? In the Zoom. I see your yes. We already had some discussion I see going on Discord. So thanks again for the presentation. And let's see, our first question is from Tom Mens. What about Chinese names and Asian or Asian names in general? Will this be more difficult? I know that you replied that you're now focusing on a subset, but do you already have some idea of how difficult it would be to scale to more types of names? David? David, can you hear me?
His mic is on, but we're not hearing him.
Then his camera seems to be on. I'll go and bring him back into the SATToSE bit. David, could you come back to the Zoom session? Yes. Thank you.
Can you hear me?
Yes.
Ah, perfect. Okay, I have not idea about the difficult about Chinese. I think that is another language. In this sense, I think that is more or less easy. But I am not from Chinese. Okay, return male or female surely is so easy. But for machine learning, I am not very good clear if how many examples I need to make the training, or what is the grammatical rules. Then okay, I need speak with some expert in Chinese to understand the difficulty.
Yes. And then, of course, that basically applies then to different families of languages that you need experts, I would guess, to go that.
The article is with Spanish and English,
yes.
But we are exploring French, and there are different results. I think that there are languages that can be similar in the structure, but we must work language per language. Then it's a proof of concept about how can I guess using machine learning, how can I get male or female using machine learning. I think that the proof of concept is so good, but we work more in different languages. I think that I have read about names in and gender in different languages, and there are many differences. We must work on it.
I'd like to go also to Hagen's question about only having two genders. I know that you said that well, the data set it's only a comprising of two genders, but how does that sit, especially in today's day and age, and many shades of gender, including genderless? Why not? How does that sit there, and what is the future work? How is future work going to address that part?
I am interested on apply this tool. I am applying in simple data sets as Forbes, scientific data sets, data sets from repositories. There are many applications. We must mailing lists, Wikipedia, many internet communities. And then I am interested on it. And I am interested to create an international data set. I think that Alexander Srebrenik is doing a very good job in collecting a lot of names in his repository. Okay, I am only collecting data sets from states, but if I want the names perhaps not very official, we can check with the APIs if it's a good tool or not.
And then finally, to connect it to my own question, I would like to also mention Tom's idea. We could try to then use your system and connect it to Mehdi's and detect the gender of bots. Well, that's half jokingly, I guess. It was very popular an idea on Discord. You noticed that. But then my question is, what is an applicability area of your research? So what would we then do? Let's assume that you would be able to also detect the multidimensional genders. What would be then the next step?
Okay, it's true that we can apply in bots in chat this tool, but I think that it's so interesting in with many names. For instance, in software repositories. In our research team is working on software heritage. It's about any people can save his or her repositories on a site. No? We have software repositories in GitHub, GitLab, Drupal, many open source projects. Then, if you have only database as software heritage, you can store your own repositories. Then, in software repositories, you can infer the number of males or females contributing source. I think that the open source project is not very gender equity, and we must improve it. And there are in United Nations there are a goal about the gender equity. Then the states must be efforts to reach it. We need measure it. We need measure it. Then I think that there are many fields of interest.
Then a final, this time I promise it's the final one from Tom. From your experience, do you think that it is possible to detect the gender of a person based on the text that the person is writing?
I think that it's possible. I have read articles, papers about it, but I am not very. I have not reproduced these articles with source. I am not an expert. I think that I have played with recognized image about faces and gender, and I think that it's with good results. But in handwriting, I have no idea. They are applying machine learning from the speeches. I think that it makes sense, but I have not reproduced with my own software these works yet.
Well, thank you very much. I mean, I think that one useful way to look at the work of this is actually as a way to try and see whether anonymity is respected. For instance, if you want to ensure that a process like an interview or a grading process is free of gender bias, then you could look at anonymity methods and then check whether your tool is still able to detect the genders, and then decide that yes, this is good enough or not, so that you ensure that it's gender opaque, the process afterwards. So that, for instance, would be for me an interesting way to explore further your work. Okay, I think that there's a lot of comment. Sorry, there are many comments generated in the Discord channels by your presentation. Thank you very much, David. And they can all find you in your coffee table in the voice channel on Discord for more questions and more suggestions and some fun. Why not? So with that, thank you very much, everyone, for the patience with our technical difficulties in this session, but also to the great presenters we had, very good and very interesting topics. And I will give the word to Eleni.
Sorry?
So this concludes the sessions, well, the paper sessions of today. Thank you all for being here. Thank you for the very, very nice presentations and the nice discussions we've had. So what happens now is that the Discord channels will remain open. I mean, people can move there. I will, for sure, to continue discussing about these papers. So I invite you all to join if you feel like it. Also, please make sure if you have questions for the hackathon to go to the hackathon channel. So there you can find Miroslav, Nuria, Chushu, and you can ask even more questions if you have about the data. And remember that in order to submit your work for the hackathon, since it's tomorrow at 2:30 UTC time, this means that it's a good opportunity to go and ask if you have questions about the hackathon. So thank you for being here today. Thank you for your understanding with some technical difficulties we've had. Let's cross our fingers, no more difficulties from now on. And I'll see you on Discord or tomorrow here as well. So bye for now.
Bye, everyone. And thank you very much. The Zoom link will be closed for now, and we will resume tomorrow. So I will end the meeting for everyone. There's nothing to save because we disabled the chat. So it's just safe to close it and see each other on Zoom tomorrow morning, bright and early. And for the rest, Discord is always open. Let's go grab some beers in Discord then.
Yeah.